What's up, everybody? Welcome back to another Unreal Engine 4 game development live stream where we're working on Project Hero, an action-adventure game built from scratch using Unreal Engine 4, C++, and blueprints and the Gameplay Ability System plugin. So today, we're going to do a kind of a lengthy live stream because of, how long these things usually take to do. So, right now what we're going to do is migrate our Project Hero from 427 to Unreal 5. So the other day I migrated from 426 to 427, and we have this right here. So just to, give confirmation that it's 427 and it works, I'll play it real quick. Yes. So we got 427. I don't know how well you guys can read that, but it's there. And I'll just jump in real quick. And it's pretty much the code base that we left off with the other day. I guess last week on Monday or Tuesday. So let's just run this, open it real quick, and then we'll do the whole process from start to finish. And so there's going to be really lengthy parts where we're actually having to compile the engine, and that can take a while. So in that meantime, there is a video I kind of want to watch together about migrating your project, so maybe we can learn something while we're waiting for the compilation. But yeah, here's our project. Obviously things are still loading, compiling shaders, but yeah, here we are. So pretty much where we left off, we're working on our slide and our super jump and everything. So, we kind of know it's working, right? So now let us go to Unreal 5. And so just to kind of set expectations, we're literally only going to be getting the engine from GitHub source. We're going to compile it from source, and then we're going to migrate our code in, and then enter content and everything. And then from there, I don't know if I want to set up a repo just yet. I might do that depending on how quickly things go and people's interests. But I do want to take this stream and then make it also a useful tutorial for migrating the project from 427 to Unreal 5. So probably next week it'll be uploaded. I'll edit it appropriately because there's gonna be some dead air and stuff throughout the whole stream. But once that's done, we'll have the tutorial set up, and if we manage to get our repo set up as well, that'll be a part of the tutorial. That'll be plus. And then we have things like Jenkins and our automatic builder and stuff like that. That's also a whole nother process. So let's begin. I think we can use the GitHub desktop application. Maybe not. I'm not 100% sure just yet. At the very least, let's make a folder. It all starts with a folder. So new folder, and we'll call it Unreal Engine 5.0, like that. I guess they have dashes, so we'll kind of work with that same naming convention like that. So we got a folder, right? And what we need to do is go to GitHub and go to the Epic Games, repository, and you can find the release version of the engine code. So we could do is actually open with GitHub Desktop. So the local path, obviously we're going to change it to where we just made it, Unreal 5.1. And then we can basically just clone it. So this is the first part, and definitely I think is going to take a little while. So I guess we can kind of just talk and chill. Honestly, I don't think anyone's in chat right now, so we can kind of just talk out loud to ourselves. But yeah, I've been wanting to make this switch for a while now. Probably ever since when Unreal 5 was in early access, but I did want to wait until it actually got released before we even attempted it. So that's why we're doing it right now. And then, basically, once we clone it, we just have to run a couple of setups, then generates files, some bat files and stuff like that. And then we compile. That's going to be the long one. So Sorry, my friend was sending me something on Twitter. So yeah, like people, most times people don't compile from GitHub or anything. They kind of just work within the Epic launcher and stuff like that, which is totally fine. I mean, you very rarely would ever want to compile the repository from GitHub unless you have any kind of intention of editing the engine, which I don't even have that intention, but yeah, that's why we're doing it. Hey Sandra, how you doing? Yeah, we're finally going to make the upgrade to Unreal 5. Right now, we're using the GitHub desktop application just to clone the current release repository from GitHub. So we're getting 5.0.1 release. And so this is going to take a little bit of time. So we're kind of vibing, kind of chilling, kind of just talking out loud about some things. How's your Monday? Do you have, I took today off from work. I don't know if you guys have the day off automatically in Serbia or not, but yeah, we have tomorrow off as well in Poland. So a lot of people gave themselves a long weekend. And so, I did some cleaning, did some other work, and now we're streaming. Finally got nip this in the bud. Very nice. So yeah, I mean, what are your thoughts on the Lyra project? Anything stand out? Anything worth mentioning? So let me also get queued up the video that I want to watch together as well when the time comes. So I'm gonna go watch later. Yeah, I think I saved it somewhere on YouTube. Here we go. So eventually we're gonna watch this video, upgrading your UE4 project to UE5. We probably don't need to know all this information, but we're gonna watch it anyway. No work today or tomorrow, but also I'm free till the 6th of June. Okay, so you already quit the job? Let's look at the process. Wow. It's taking a while. Yeah, pretty much. You're like, peace out, deuces. I mean, yeah, why not? If you don't need to work, give yourself a nice sabbatical. Not sabbatical, but maybe sabbatical. Just like a longer vacation holiday. I made the bad mistake of like when I left Digital Arrow and joined PCF. I literally, my last day at Digital Arrow was on a Friday, and my first day at PCF was that Monday. And so like I literally just gave myself like 2 days of relaxing before starting the new job, but I also had to do the move and everything, and that was stressful. So like I did not give myself the break I think I should have deserved when making the switch. I wonder if it would have been quicker if I were to just have downloaded it and unzipped it. Probably, but maybe it's better to clone it. So we can get like updates to stuff. Like easier going forward. Yeah, I mean, honestly, try to relax a little bit. Don't drive yourself up the wall. But yeah, if it's nice, to be able to hit the ground running and everything. So, I'd say go for it as well. Do you, whatever you think is best. Right now, we're not even halfway yet with this cloning. And right now, like, I don't think you can hear the music that I'm playing, or it's really low, because right now, like, I want to make a YouTube tutorial out of the stream. I want to have like I want to make sure I don't get copyright striked or anything. So, after we get everything done and working, I'm going to edit it and cut it down and make it a tutorial. Like the actual tutorial itself will probably be like 5 or 10 minutes long, where it's just like, okay, go to GitHub, get the repo, and then, skip over this part after it's cloning, then do the setup.bat, and then do the generate project files, and then do the engine association, and then do the compile. And the compile is going to take like, I don't know, an hour, maybe an hour and a half. And in that meantime, we're going to just do some bullshit, like watch some videos and stuff. And so we can skip past that. And then once we do that, we can literally just kind of copy paste our content in source code into the folder, update our plugins, and there it should work. So that's pretty much our goal. And it's, the migration that I did from 426 to 427 was the easiest one I've ever done. Like, usually I have problems. That one was like super smooth. So I'm hoping it's also going to be super smooth. Going to 5. So I imagine it would be. It's just kind of time consuming. And then, once we're into 5, this is where like a lot of questions will kind of come into play. Like, it's like, do we then want to migrate our stuff using the enhanced input system? Do we want to take more information and a lot of practices and principles from Lyra and integrate that into our framework for Project Hero? Like, there's a lot of outstanding questions that we'll have to answer, because like, if we're gonna move to Unreal 5, we might as well take advantage of some of the things that Unreal 5 comes with. Obviously, we don't really care for things like Nanite and Lumen too much. Obviously, those things are nice, but we are having a more stylized game, so we don't really need to have those kind of features. But we also will want to, like, in theory, we want to support a very large environment. So we're definitely have to look into some of the tools that they offer there for like landscaping. And, obviously this wasn't like Unreal 4, but they have like the water tool where you can build rivers and lakes and other bodies of water that we want to investigate as well. But I think, the first thing, after we kind of do the migration and we set up our Perforce, and we set up Unreal GameSync again. And then we got to do Jenkins. We got to set up the automatic builder. We got to make sure that's okay. We have to update our Python scripts. So is the water tool at all better in 5? Did they make any kind of changes to it, or does it still suck? Or does it not work as you wanted it to? But yeah, once we get Jenkins and our automatic building, then we would then we would start considering what we need to change, right? I definitely would want to do the enhanced input system. I would also like to make a tutorial about the enhanced input system, how to set that up. And then once we get that, I would like to, possibly use Lyra's inventory system for our weapons and stuff. So yeah, this project is endless. But yeah, I'm one guy, so I can't do much about it. All right, 80%. We're almost there. Not much really. I don't know what else I can say. So I don't know. It's hard to fill in dead air sometimes. But yeah, but what's this thing? Watch our evangelism talk, upgrading project. Okay. Thank you for using the abandoned apartment scene as an example for conversion. Its visual quality is exceptional, and the conversion shows that having foliage in your Lumen and Nanite scene isn't a deal breaker. This is incredible. Okay, so apparently this video seems to be worth it. So I'm glad. I'm glad that's the case. I'm curious with this cloning thing. Like, I don't see any assets yet. It's only receiving the objects. I don't know what that means. So we're in some trouble. Probably not. We're fine. Everything's fine. I'm gonna play the YouTube video when we actually do the compiling, because I know for sure that part's gonna take a while. So right now we're 20 minutes in, and yeah, we're still cloning the repo, but this is going a little faster. We're almost at 10%. I think now we're actually getting the files, or not. I don't know. But yeah, if I need to play videos, I should definitely increase my volume. And maybe we can watch something. I guess maybe I would just start watching this video.
Can't wait to see what you create with it.
Can you hear that?
Of
well,
course, not everyone is starting their projects from scratch in UE5. Some of you have already started working on your projects in UE4 and are probably wondering whether or not you should upgrade your project from 4 to 5.
I should be louder.
This video should hopefully help you make that decision and smooth the path as you go through the upgrade process. The great news is that unlike Unreal 3 to Unreal 4, you can in fact upgrade.
All right, I'll pump up the volume a little bit for you.
Unreal 5. It is not, however, as simple as right-clicking on the U project file and switching engine versions, and we'll show you some of the
subtitles on as well
to take in order to fully convert your project, highlight some potential issues to be aware of, and offer some guidance on workflows to help you expedite the process. But first, let's talk about when and why to convert or use UE5. If you're just starting your project today, then we highly recommend starting your project in Unreal Engine 5 to be in a supported version of the engine that we will continue to improve and to develop in the years to come.
I wonder if it's going to be like, if there's going to be a UE6 at some point.
Experience demo, which we launched at the end of last year. If you haven't seen it, definitely check it out. There are numerous factors that will influence your decision, and we hope to provide you with the information you need to make it. If you are developing a game, we've got a number of amazing new features that will empower you to develop immersive experiences that you'll surely want.
Okay, still stuck at 16%. Cool.
From Lumen to Nanite and everything in
between. Yeah, so we definitely want some of the new features. We don't care about Lumen and Nanite that much.
If you were using the engine for other projects, ranging from film and TV shows, animation, architecture, or product visualization, it's worth noting that some features of Unreal Engine 4 will continue to be available and function just as they always have, or have seen some improvements. GPU lightmask baking, switchboard, multi-user editing, and the new console variable tool all improve the experience of operating an in-camera VFX stage, for example. However, some new UE5 features may not fully support all use cases. For example, Lumen and Nanite have not been fully tested in in-camera VFX workflows or are not supported with the Path Tracer or VR. We will, of course, continue to improve these features and their support over time.
I guess we could also watch like the guided tour as well.
Some features have been deprecated or removed altogether.
Okay, this is important.
World composition levels will need to be updated to world partition, cascade particles will need to be converted to Niagara, and so on. We understand that the conversion will require a fair amount of effort, and hopefully this video makes the process a little easier for you. When converting your project to UE5, it may make more sense for you to upgrade from the current version of your project straight to UE5. If you were to update version by version, you may end up doing extra work to get your project working in each of those versions before you finally get to UE5. We think it's better to get it all out of the way at once, although this is something we suggest you evaluate carefully with a backup copy of your project before committing to a
Yeah, so this is basically what I had to
Even
do.
if you're
So I
just
went from
thinking about upgrading
426
your project
to
from 4 to 5,
427,
we
now to
recommend
5.
you do so as
That
soon
is one
as
thing that got so
possible.
complex I
The
can't
longer
keep
you
up with
wait,
it.
the harder
Well, I mean, there's
it will be
lots,
to
like, from what I
upgrade, as
understand,
more and
obviously
more
I
things
don't do
change.
VFX or
Unreal
anything,
and
but
UE5 diverges further and further
like
from UE4.
it has a lot of
Some of the key
similarities to
benefits
like
of
how you do
upgrading, of
blueprints
course,
and
are
stuff.
access to our new rendering
Like you have a
features
lot
like
more
Nanite,
interesting
Lumen, and virtual shadow
visual
maps.
scripting like control, if I'm not
Nanite is Unreal
mistaken.
Engine 5's new virtualized geometry system that uses a new internal mesh format and rendering technology to render pixel scale detail and high object
But yeah,
size.
like Cascade was already kind of
Intelligently does the
difficult.
work on
I can only do the
detail that
basics
can
in
be
that.
perceived and no more. Nanite's data format is also highly compressed and supports fine-grained streaming with automatic levels of detail.
Okay,
What's
we're
more,
at
Nanite
33%
can be
now.
beneficial for even very low resolution geometry. Any static mesh that has opaque materials without world position offset can be Nanite, and anything that can be Nanite should be Nanite, since it will have benefits for both runtime performance and memory usage. Lumen is Unreal Engine 5's
But also
new,
somehow
fully
somehow
dynamic global
abstract.
illumination and reflection
I mean,
system
I've
that is
never really
designed
opened
for
up
next
Niagara.
generation.
Maybe I should.
Lumen is
Maybe
the
when we
default
get the
global
5, we can look at it.
illumination and reflection
Like, I don't know
system
if I
in
have to,
Unreal
like,
Engine 5, and it
do I have to
renders
take the
diffuse
particles that I'm
reflection
using and make them
infinite access
Niagara, or
and
is there an easier way to do that, or do I have to, like,
detailed
because a lot of the stuff I have is
scale
from
change
Marketplace, you know, and they were from 420, you know,
global
Unreal
illumination
4.
system, it's possible to achieve incredible visual results
So I'm not
with
sure
fewer
exactly what
lights
we
and
would want to do.
systems, while at the same time improving iteration times since the system reacts so quickly to your changes in lighting. In addition to the new lighting and geometry streaming technology, we've also introduced a new method for casting dynamic shadows called virtual shadow maps. These are very high-resolution shadow maps, and to keep performance high at reasonable memory costs, virtual shadow maps split the shadow map into tiles or pages of much smaller size.
Oh yeah.
These pages are
I guess it would
allocated
make sense because
rendered only
Cascade
as
and
needed to shade on
Niagara, they're
small
kind of
pixels
two
using
completely different
plus
systems.
The depth buffer. The pages are cached between frames unless they're invalidated by moving objects, material effects, or light, further improving performance. These perform exceptionally well with Nanite geometry, because Nanite geometry can be culled and occluded at a finer granularity. So when the system is drawing shadows for a given page, it only considers a smaller set of geometry that overlaps that page, even if the instance is much larger. Additionally, Nanite's automatic level of detail ensures that the triangle density matches closely with the resolution of the given page. So now you can have high-resolution dynamic shadows much farther out into the distance without causing significant performance problems for your project.
Yeah, that's insane.
With all the powerful new technology behind Unreal Engine 5, let's take a look at an example of converting a project from Unreal 4 to Unreal 5.
Here we
My
go.
colleague Galen Davis is going to show you how he upgraded Quixel's abandoned apartment environment to use the new features in the engine. Take it away, Galen.
All right, so let's start converting this scene. So the first thing I'm going
Oh,
to
they're going to be doing it through the marketplace. They're going to do it through the Epic Launcher, not GitHub.
So
So
what I'll do inside the marketplace tab is actually just go up to search products, and I'll type in Quixel here at the top. And I would really encourage you guys to take a look at all the free content that we offer here inside of this section. But today we're going to be focused on the Megascans Abandoned Apartment project. And I already have this scene downloaded as per 427. And so that 427 scene already exists on my drive. And it's really easy after you've downloaded it. You can just create a project. You can have the launcher create the project using 5.0. And that's one way you can actually just start by opening the scene and getting going with 5.0. The other way you can do it is, since I already have the scene already downloaded on my drive, I can just tab here to where I have it locally. So this is where the U project lives on my drive.
I'm just checking up on everything.
I can right click this guy and just say open with. And I've already gone to the binary section folder where I've actually targeted the Win64 version of this. And I'm just
I'll full screen this thing.
Unreal Editor here. All right, and so what this is doing is just pulling up the scene here in the background, and it's going to load everything.
I like how it's just a black fucking screen. There you go.
So one of the things that we'll be able to see here in a second is that ray tracing is actually enabled in this scene. And this is something that we're actually not going to be using for the 5.0 version. We're actually going to be converting everything to Lumen. We're also going to be working to establish any mesh in the scene that can use Nanite.
Damn, that looks really good.
To Nanite using the Nanite audit tool and some other kind of cool tricks here inside the editor. All right, and so the first thing that I want to do here is actually go up to my project settings. And what we're going to do from here is actually start to change some of the things that we want to do today in order to improve the visual fidelity of this scene and use some of the new features here inside of UE5. So
I don't, again, like, I don't know if we want to do anything with rendering and stuff. We can try and just see what happens.
Is actually go down here to dynamic global illumination method. And I'm going to set this to Lumen. And what you're going to get here just to start are a couple different flags. And this will tell you that there's a couple different things that need to be activated here in addition to just changing dynamic GI here in the project settings. So I'll click OK on all this stuff. You're seeing we're going to generate mesh distance fields and a couple different things. But the key is that we're going to have to restart the editor now. All right, so we're here back in the scene. And the first thing you're going to notice is that all those warnings that we had before are now gone. So a couple different ways that we can actually check this just to ensure that we're actually going to be working from the right starting place here is I can go up to a couple different visualization modes that will actually show you that we're actually working with Lumen and some of the new systems. So the first thing I'm going to do under the Lit tab is go down to Lumen and look at Lumen.
Lit tab is the best tab.
Here is a kind of primitive version of what the scene actually looks like from a lighting perspective. So Lumen scene is basically just showing a really rough approximation of what's actually going on here. And what it's going to show is just how the bounces are actually working in certain parts of the scene and what areas we need to kind of make some modifications. And so we'll go into some of those specifics here a little bit later. But the next thing I want to show is actually go down and look at, in the visualization tab, you can look at mesh distance fields, okay? And I'll switch this back to unlit so that we can see lit mode rather, so we can actually see the distance fields here in this viewport.
That hurts my eyes.
This doesn't look like a ton of information here to start, but this is actually super informative here as far as the density of the voxels that actually go into creating the mesh distance fields. And we can actually look to improve this later on, but we'll come back to that a little bit later. Okay, so we're going to start by actually going through and deleting all of the lights in the scene. And I'm going to hide a couple of these here on this side. These are just some ambient boosters that we might come back to at a later point, but for right now, they're just not super important. So I'm going to delete the directional light and the skylight here. And I'm also going to go through and delete the light mass importance volumes. And like I said, I'm going to hide some of these other light transmission boosters that we've placed in the scene.
I'm curious what the end result's going to be.
I'm also going to do away
Let me
with the sky.
just check our progress. 86%. Nice. Okay, this is moving kind of quick. Still has a little bit more to go. All right, here we go. All right, so now that we have the repository cloned onto our drive, we can actually now get officially started. So there's two things that we got to do. So the first one is setup.bat. This runs a bat file that does checks for dependencies, downloads any other missing dependencies from the internet, and then, you know, asks us to install whatever might be missing. It'll give us warnings as well if something is missing. We should be okay because of where we are in 427. So this process will take a little bit of time, but we can just kind of wait it out. Should be like 5 minutes or less. So in the meantime, you can jump back into this.
Box, so I'm going to go ahead and delete that. So if I switch to unlit mode, you can see that we really only have just the cameras and the geometry that are sort of making up this scene. And we're going to go through now and start to reintroduce these new systems back in with some of the newer systems in UE5. And this specific project was actually created before the Sky Atmosphere system was even implemented into the engine. So we're going to be able to actually drag that in today and use that system to light the scene. So let's go ahead and get started.
I wonder if we would have to use that as well, because we have that skybox thing that we converted to C++. We got from the marketplace. Like, do we need that anymore? I don't know.
The first thing I'm going to do is actually go to this new quickly add to the project tab up here at the top, and I'm going to go down to visual effects. And the first thing I'm going to drag in is actually the Sky Atmosphere system. And if you just go to lit mode, you won't see anything just out of the box with that. We need to actually add in a couple hooks that will allow us to actually use the Sky Atmosphere system. So the next thing I'm going to create is actually a directional light. And while we're here, why don't we also just add in a skylight? And these are kind of the main components that we're going to be working with here as far as relighting our scene with Lumen. So first thing I'm going to do is actually make sure that both of these lights are set to movable. And I'm going to scroll down here in my directional light, and I'm going to find the tab here that shows that we want to use this light specifically with our sky atmosphere.
Let's just check. Okay, we're 25%.
System. So if you look into the atmosphere and cloud tab, you'll see that the atmosphere sunlight is actually ticked on. And we want that ticked on because we specifically want to be able to use the sundial in relation to the sky atmosphere system and the directional light. We're also going to make sure that we have cast shadows on clouds activated and cast shadows on the atmosphere.
Oh, hey, what's up? How you doing?
You know, with these different
how's UE5? Right now, UE5, you know, I've been using it a little bit, but yeah, right now we're working on upgrading our project from 427 to 4 UE5. So right now we just finished cloning the GitHub repository of the engine, and now we're running the setup.bat. So right now it's just checking and updating dependencies, and in the meantime we're kind of just watching a video about migrating the projects from UE4 to UE5. So basically, after we're done with the dependencies, we run the generate project files.bat, and that will give us a solution file we can then open up in, we'll be working in JetBrains Writer for our IDE. And then basically we just have to compile the engine, and compiling the engine will take maybe an hour and a half or something. I don't remember. And then, yeah, that's pretty much the big parts of it. And then, yeah, then we gotta move our content and our source code into this engine, and you know, update our association of project files and stuff like that. And then we also have to update some of the plugins that we're using, and then, you know, hope for the best. So yeah, it's a slow process, but you know, I'm doing this so I can also have a tutorial that I'm going to use this live stream from. You know, I'm just going to cut it and edit it and everything just to make a tutorial I can upload onto YouTube, and as well as my Epic community page on the Unreal forums, because you can have, like, under your profile, I think you can have tutorials and stuff. So I'd like to add a tutorial there. So that's going to be the goal. And obviously at the end of it, we'll have Unreal 5, and then we can start using the features that we have for our project and kind of move forward from there. Obviously, just today, we're going to work on getting the editor running and having our project open. Maybe set up Perforce as well, our new repository. If we can get both of those done, I mean, that would be a pretty productive day. So how are you doing today, man?
Turn those on or off here. We also have the opportunity to take a look here with the skylight to make sure that we're getting ambient occlusion from the actual clouds here. So if you just scroll down here, and you can even just do a search and make sure that cloud atmosphere or cloud ambient occlusion is checked on. That's another possibility if you want.
Yeah, like the whole thing with tutorials and stuff. It's hard because, like, you know, you don't have tutorials are hard because, you know, there's certain topics that have been covered a billion times already, and you know, there's some trouble finding the time to actually set up a tutorial because there's a lot of work that goes into that. I like to try to do more obscure or more at least useful topics when I try to do tutorials. So I'm hoping this will be one of those cases.
So those are the kind of the main features that we're going to be looking at. So I'll go back to lit mode, and as you can see, we've got our sun here over in the horizon, and we want to actually move this now to where we get the sun kind of pouring in through the main window here. So now that this light is set as our dominant directional light, we can actually go in with Control L and actually move the sundial around.
That's cool. Control L does that. That's cool.
Seeing all the global illumination in real time start to update here in our scene.
That's pretty cool.
So I'm just going to find an angle for this that I kind of like, that's bringing a decent amount of light into the scene. And I think that this is looking pretty good here. So why don't we go now to our skylight and just bump up some of the intensity on this light here. So I might set this just to 2. And this is just going to fill in some of the areas that might otherwise be a little dark. And the same thing with the directional light here. We can start to play with the intensity of this. I might bump it just to 15, just so we bring a little bit more light into the space here.
And
Really
that's
don't
pretty
want
cool how
tons of
quickly you
super
do
dark
that.
spots in this environment. We're going to do some material changes in a little bit, but just to start, I want to make it so that we're actually getting a really solid starting place here. So again, I can go and start to preview what the Lumen
Oh, well,
scene actually
I always
looks
hear
like.
such
So if you
interesting
want, you
critiques
can-
about Unity, or like, you know, I see some developers in Unreal Engine saying, oh, you know, the documentation sucks, there's no information out there, the tutorials are terrible, Unity is better, and then you're saying the tutorials, it's hard to find a good tutorial. So it's like, you know, pick one. What like why is Unreal bad if you can't find tutorials? And then you know, I'm hearing contradictory things, you know. But, you know, Unity as itself, as an engine, it's valid. I mean, it's been valid for a while. And, you know, a lot of the engine architecture is more or less the same, I would imagine, you know, the workflows and stuff like that. So I wouldn't imagine it being too bad. Really gotta clean this desk. Like, dust and crumbs and shit. Your team Unreal Engine? All right. So now it's done checking the dependencies. Now it's going to install the prerequisites, and something you may notice, you might not see right away, is at the bottom, you'll have, you know, Windows pop up. You'll have to agree to it. I don't know if you'll see that, but, you know, it's just asking for permission to install everything. So for you guys, it was just a black screen, but you'll just say, hey, you know, Unreal wants to install some things. Is that okay? All right. So setting up is done. Now we need to generate the project files. So this is where it may give us an error. Maybe we're missing something. I forget what some of the things that you might need. I guess like the .NET stuff would be something you might be needing. Log file, blah, blah, blah. Some platforms were skipped due to invalid SDK setup. Those are fine. We don't care about Mac, iOS, Android, and everything like that. We really just care about PC and I guess console. Maybe, yeah, we don't care about mobile. So now we gotta let this do its thing. When it's done, if there's no errors or anything, I believe it will automatically close. Otherwise, it'll just have like a confirmation prompt being like, yeah, you good? You know, go ahead, close it. It might ask us to do something, I don't know. So we'll just have to wait for it to do its thing. Maybe sometimes you have to press enter. There you go. So now it's binding IntelliSense data. This is what the build tool is doing. So we're writing project files. Okay, and we're good. So here now we have our UE5 solution file. What I like to do first, though, is go to Engine, Binaries, Win64. There is the Unreal Version Selector tool. We want to say, do we want to register this directory as an Unreal Engine installation? And we want to say yes. Registration successful. Cool beans. Now we can open up, again, we're going to be in Writer. We're going to open up the solution file. Trust and open. We're going to have a nice, sexy README while the solution is opening up. And, you know, Writer and all this stuff, it's going to take a couple of minutes because it's the first time opening it. It's going to have a lot of things that it wants to do. So we just got to wait. And then once it's ready, you know, it's syncing. You can't see this kind of because of where I am on screen, but it's syncing the projects. It's going to load the code solution. It's going to load the data that it needs in order to do the autocomplete feature and stuff like that. So it's going to really hardcore do its job here. So yeah, in the meantime, we can jump back into this for a couple of moments.
You can go down here to visualize, and you can take a look at the mesh distance fields again to just sort of check on the quality of the distance fields as it relates to the actual assets. If you might find that there's some weird shadowing, we can go back to lit mode here and check out under Lumen, the Lumen scene. Then we can start to get a good idea of what is working and what is not working here in our scene. All right, so now that we've got our lighting basically stubbed in for the purposes of this demo here, now we want to actually go and indicate that the assets that can use Nanite should in fact be using Nanite. And one really quick way to do this is actually just go up to the Tools tab, and you can scroll down to Nanite Tools. And Nanite Tools will actually allow you to take a look at assets that are all throughout your scene.
Okay, so it does it in the scene.
Start to actually give you an indication of whether or not the asset is using Nanite or is not using Nanite, and which ones have problems based on their current setup. So what I'm going to do is actually go over here to the Optimize tab here to start, and I'm just going to set my triangle threshold to 1. And what this will do is actually allow me to...
Okay, for some reason my screen, I can see my stream flickering or something. That's kind of weird. Okay, so writer's ready to use. Okay, we're good. That's good. Right now, you can't see this as well, but I can bring this up here. Right now, it's indexing. So we're going to let that do its thing as well. Again, it's going to take just a few minutes, so we're just going to wait that out. In the meantime, we'll wait for the updating indexes. The whole process thing, we're not going to wait for that because that could take forever. So yeah, in the meantime, you could just watch this again. Maybe not watch it in full screen because it might cause flickering.
Could in fact use Nanite. So what I'll do, since we've got this long list of assets here, is I can just go to the Enable Nanite section here, and this will go through and start to process these different assets so that they will start to build proxies for them and start to make it so that everything in our scene is actually using Nanite. So I'll fast forward here a little bit, but just know that everything is being processed behind the scenes, and when we come back, we'll have everything set up to Nanite that could be set up as Nanite. All right, and we're back. So now everything that can be Nanite is set to Nanite. And what's really nice about this is that
was there a difference though?
Process a huge amount of assets without.
I don't see much change in the scene really.
And indicate which assets should or should not have that designation. The only thing I would
do you write pseudocode as part of tech design documents? No. I don't think that's really necessary. Maybe it could, but no, I don't personally. Like, if you're looking to, like, the technical documentation should just give you as much information as you need. Obviously, pseudocode could do that. Like, you know, you have like those diagrams of pseudocode, but you know, for things that we do at work, I don't see it. I see it as more of like you'll need the pseudocode to do, like, kind of describe a process. Like if you want to describe, I tried it recently and programmers loved it. I mean, cool. That makes sense. It really just depends on the people. Personally, I don't think it's necessary. Like you can literally just, you know, open up the blueprint and look at it. Like that's kind of what the thing with Unreal, you know, there's a visual scripting aspect and it's pretty easy to follow. Whereas if you're constantly writing, you know, line code, yeah, maybe having pseudocode there in part of the documentation is useful. But when you have blueprints, most times they're very simple enough where you can just literally look at the picture of the blueprint and be like, okay, I kind of know what's happening. All right. So now it's doing its process and it's git log indexing. Actually, let's let this also finish. We can kill some time. It's probably gonna take another like 5-10 minutes or something. We can continue watching this.
The caveat here is to review the documentation specifically around the elements that are not currently supported by Nanite. We're obviously updating this as new developments come in, but some of the things to be aware of just with this scene specifically is that there were some world position offset elements in some of the materials and two-sided materials on some components. Those are, as of the recording of this video, need to be deactivated. So just something to be aware of specifically as you're going through and making some of the same changes that we're making here. I would also make sure to take a look at a lot of the documentation around how to make your scene better as it relates to Lumen. So I'm going to show one really simple example of how to do this. So with this hallway back here,
oh, it's kind of like vibrating.
You may notice is that this entire hallway is set to one single piece of geometry. Now, this isn't necessarily that problematic, just in the way that scenes have been created in the past. But for Lumen, we can actually increase the visual fidelity of these types of environments by indicating that these different pieces, these walls, could actually be separated in a sense. What we're going to do to start is actually open up the modeling toolkit. So if you go to the select mode,
Oh, there's a modeling tool. Interesting.
just to the modeling section. And what this will do is open up a brand new window for you. And there's a lot of different tools in here. I definitely encourage you guys to take a look at all the different components that make up this specific window. But today we're really only going to be focused on one specific element of this right now. So with my hallway selected, what I'm going to do is actually go to the triangle select section here under try model. And what this will do is allow me to now start to select based on a couple different elements here. So what we can do is selection mode here. I'm actually going to change this to all within an angle. And just out of the box, this works here because this angle is set to where I'm only getting just this designation of, you know, this degree angle specifically on this wall.
Okay,
now,
let's check. This whole process thing, I hate how long it takes. I guess we don't care. We can let that do its thing. So let's jump in and actually compile the project. So you have the engine, you have UE5, right? And for writer, towards the top here, I don't know how well you can see it. Basically, you tell it what project to actually compile. So we just want to find UE5. And then in writer, we can just press F5. And it'll start to do the compiling process. And yeah, this one's the longest part of the whole process. It has to compile thousands of objects. So right now it starts with, 73 stuff. So we can kind of wait this out, but then I believe it will jump to having to compile like, I don't know, 40,000 or something like that. Maybe UE5 is different because that's just how it's been for Unreal 4. Maybe they changed how that works. So we're just gonna, take our time here and watch what it's gonna do. And I don't know. We can talk about anything you guys want in chat. If anyone's interested in any certain topics or have random questions or... like, I've been doing a lot with yard work yesterday. And like, my hands are so cramped and stuff. Like, if I just kind of like stretch out my thumb like this, like, it feels good, but it hurts so bad. So, like, I gotta, I don't know, just do some stretches or... I don't know if it's like carpal tunnel or something. I don't know. But it sucks. Then yeah, I did some, like with the yard work, I was using a hoe to like, pull up the grass so I can have like a layer, like a leveled layer of dirt that I can then put tiles on top of, and then I can have like a nice tiled backyard for half of the backyard that I can then add an overhang onto, and I can add some furniture, and then by hopefully the end of this month have a nice like backyard vibey area just so people can chill and have fun. Vertical mouse is great if you have carpal tunnel issues. Vertical mouse. Huh, interesting. How does it work? I might give it a try. I'll save that for later. Thank you. All right, now it's moving a little faster. Using it for like 2 years. I'm never looking back. Same as the regular, but the English trains are less. Interesting. Okay. I'll definitely check it out. Thanks. Okay, so yeah, we're done now with the 73 initial objects that I wanted to build. Now let's go check the actual editor thing, and yeah, I'm pretty sure vertical mouse is a style statement. Yeah, we got all the cool people who do vertical mouse instead of the normal one. Okay, so the reflection code was generated. So very shortly, it should say how much it's going to be building. Okay, this shader, yeah, okay, so not too much actually. It's like 5,841 objects to build, and now this is the longest part of it. This might take an hour. So in the meantime, we'll go ahead and kind of watch videos together about Unreal Engine and just wait that out. So let's jump back into the Nanite.
Only thing I need to do now is actually just go here to separate. And separate will make it basically its own component.
So it's a gamble. A guy I know never got used to it. While it took me like 2 days, so try a cheap one at first. Okay.
Asset here, and you can see that now this wall is separated out as its own component. Again, I would refer back to the documentation specifically around Lumen to show why this is important. There's a lot of different reasons to actually go and separate these pieces out. The main reason being here for this example that we want to increase the visual fidelity and also make it so that we're feeding Lumen all the necessary things to make it do its job the best that it possibly can. So just one more time here.
So yeah, definitely this video was not what I was hoping it was going to be. I thought it was going to be more information about how to actually do the migration. This is literally just changing your lighting setup to use Lumen, but still good information, I suppose.
I can just select this wall here, and I'll go ahead and click separate here and click accept. And that's just one of the ways you can go and start to make improvements to the visual fidelity with regards to Lumen.
Like some of these stuff is kind of low quality textures.
Documentation specifically around the surface cache and why it's important to break up walls like this specifically for interiors. Another thing that you can do is actually go in and start to adjust materials here. It's really important to make sure you have really bright albedos in order to kind of get the necessary balances here that you want for your scene. So just looking back here at this hallway, you may notice that this trash can seems just a little bit darker than some of the other elements in our scene. So with the Megascans material, you can actually go in and start to affect the albedo tint here. And you can also go in and start to affect the intensity of this tint. So
right now it has no tint.
Just set to white. If I multiply it by 2, that will just increase the brightness of this asset 2x. And again, I can go through and do this for a couple different assets in the scene. This is just something that will just overall make it so that Lumen is making sure that it's getting the best possible information going in and make it so that all the bounces are being maximized. Then I would make sure just to do this on
like for some reason that texture on that wooden palette just looks like trash. I don't understand that.
Of the environment that you're working inside.
Like the foliage looks nice.
Touch on here today is actually bringing in the cinematic high master versions of all the meshes that we're looking at today. And this is one of the features, in fact, of being able to sort of work with Nanite and bringing in all the additional triangle detail is something that will really.
You think it's the lighting? Okay.
Fidelity of everything that we're looking at here in our scene. So let's use this table here as our subject. So what I want to do is go ahead and make sure that I have the standalone bridge version installed on my PC. And I'll go ahead and tab to that now. All right, and here we are inside of Bridge Standalone, and what I'm going to do, since just for the sake of time...
Yeah, everything does look noisy, it looks blurry, very low quality.
But one thing you can do, just to ensure that you do have the highest resolution version of this asset, is actually go to your download settings inside of Bridge Standalone, and you can go to Models and just make sure that High Poly Source is currently enabled for this download. One other thing to note is that when you're working with the Cinematic High Master Mesh, you want to make sure you're using the normal bump component as opposed to the normal map. So that's just one note to make sure that you're getting the best possible look for these assets. So what I'm going to do is actually go to the files around this asset. So if you right click on the tile, you can just click go to files. And what that will do is actually indicate that you have a folder here with all the necessary components in. So I'm actually just going to copy this location on my drive, and I'm going to tab back over to Unreal. So I'm
curious how this will change and look
here. One thing that's really important is
when he makes the update
that you already have this asset designated as Nanite. And so one way we can check this is actually just go into the actual asset here, and you'll see at the top that Nanite is currently enabled. So that's the first thing you're going to see in the top left corner here. And that's just really important because if you do it without having Nanite enabled, then it will actually take a much longer time in order to import the asset and convert it to Nanite. So again, make sure that you already have this asset set as Nanite. And then what we're going to do is actually re-import with a new file. So I'll right click on the asset and I'll re-import with a new file. And then I'm just going to paste my directory here directly into the search tab. And I'm going to indicate this is the high resolution version that I want to bring in. And I'll go ahead and click open. All right, so we've successfully re-imported this asset. So if I just go and inspect this asset here inside of the viewer here for the static mesh, you can see that we have over almost 2 million triangles actually with this asset.
Damn.
And it's just a much higher resolution version of this asset than what we have.
2 million triangles for just the table.
This is something that you could do over and over and over again inside of the scene until you get all the necessary components at the resolution that you're looking for. One other thing that you could do specifically with an element like this floor is actually go in and indicate that you want to displace the asset specifically by using the displacement associated with that material. Inside the modeling tools, there's a really easy way to just grab a displacement map that's associated with the tiling texture that you're looking at, and then displace it basically just from that map inside of the editor. All right, and then just to wrap up, I went ahead and just made some modifications to some of the camera settings specifically with this environment. So why don't we go ahead and take a look at the end result. All right, guys. Well, thank you so much for watching this section of the video. We've got a lot more.
Okay, so this is the end result of what he did.
Share it with the community.
Okay.
As you saw with this scene, we were able to just quickly take a UE4 scene and convert it to UE5 and increase the visual fidelity. And in this instance, we were actually able to increase the overall performance of the scene as well. Moving from the real-time ray tracing setup that we had before and converting it now to use Lumen just really makes a significant improvement just as far as the overall frame rates for this specific scene that we're working on today. Okay, and with that, I'm going to pass it right back over to Matt.
That,
Thanks, Galen.
interesting enough.
Since every project is different, we also wanted to talk a bit about some of the other aspects of your project that may need to be upgraded once you get your project into UE5, including updating your assets to Nanite, virtual shadow map performance considerations, converting your existing Cascade particle systems to Niagara, converting your maps to world partition.
But we definitely have to worry about
precision large world.
I don't know if we have to worry about our meshes going to Nanite or not.
Some deprecated UE4 features that have now been removed.
I guess we would have to take that in consideration.
We'll also include some handy tips on how to identify these issues that may need to be addressed as part of your upgrade process. To help you identify candidates for conversion to Nanite, we have the Nanite Audit tool. This works only on static meshes loaded into memory.
Yeah, I mean, like the scene that they're showing right now looks kind of stylized. But yeah, our project hero is super stylized, so yeah, I'm curious as well.
You'll need to get them loaded into memory. The easiest way to do that is to go to the content browser, click on the content folder, and filter for static meshes. Then you can hit Ctrl-A to select all, then just right-click. This process is much faster than it was in UE4, so even on larger
It doesn't work with
projects,
mass materials, okay.
At all.
Good to know.
You can go to Tools, Nanite Tools, and switch over to the Optimize tab. This will show you all the static meshes that should be Nanite. You can also lower the triangle count threshold to make sure you're getting everything in your project. Then all you have to do is hit the Enable button in the bottom right corner. This process may take some time depending on the number of assets that need to be converted and the polygon density of those assets. So sit back, grab a coffee, maybe check out Chris Murphy's guided tour of Unreal Engine 5 or any of the other UE5 videos that we've released. Nanite may not be available on all platforms, though. Nanite will generate what are called fallback meshes, which use the base Nanite proxy as effectively LOD 0. Then, depending on the number of LODs you've set on the mesh, either explicitly or through the LOD group, it will generate additional LODs that will be used in the event Nanite isn't available. You can easily set the LOD group of a lot of static meshes really quickly using the bulk edit via property matrix tool, like so. Alternatively, you can now set either the LOD group or explicitly the number of LODs through an editor utility blueprint using the static mesh editor subsystem, like I'm showing here on screen.
Interesting.
This is an asset action utility, so it'll show up in the context menu when I right-click on the asset in the content browser. Now that you have Nanite set on your static geometry, you may consider importing higher resolution meshes, since Nanite...
Good call, video narrative. Yeah. What's my hydration choice? Like right now I have water,
depending on the size,
but I think I'm going to make a coffee after this video.
This process, and there are numerous ways to
I bought myself a coffee machine.
We understand that
the capsule-based coffee machine. It's pretty good. So after this video, for sure, I'll do it. So we still got like 15 minutes left.
Before you trigger any kind of import. Perhaps the simplest solution is to export the new Nanite resolution mesh to the same FBX location as the original, and trigger a re-import on those meshes through the right-click menu in the content browser. You can select multiple assets and re-import them all in one go instead of manually re-triggering this per asset. Of course, with the increased fidelity of geometry and higher triangle counts comes disk space considerations. We look forward to continuing to improve on the memory footprint of Nanite assets and recommend that intermediate formats such as FBX are not part of the set of data downloaded by most users for
source control. On
the runtime side of things, there's some good news. Because of Nanite's specialized mesh encoding, its size in memory is significantly smaller than the standard static mesh format. For example, this 2 million triangle clip.
Yeah, I got
from
really
Pixel
good
Megascans is
capsules. I got one for
226
like
megabytes
caramel
in
flavor,
monostatic
vanilla
mesh,
flavored. It's all
which
really
includes all
good.
of its LEDs. However, if it uses Nanite instead, the maximum streaming memory allocation will be about 35 megabytes. As you transition more assets to Nanite, it may make sense to turn
They have a
off
manual
hardware
grinder at
occlusion
home.
queries in your project settings. Traditionally, you'd want to leverage occlusion to make sure
Yeah,
that
you had to put in a lot of manual labor into make a
users.
coffee. That'll probably
The
stop you
trade-off
from
is that
having
it takes
coffee.
some amount of time to calculate that occlusion. Generally, if the amount of time to calculate the occlusion is less than the amount of time it would take to render the occluded geometry, this will be beneficial. In UE5, Nanite has its own internal occlusion and culling, which doesn't use the traditional hardware occlusion path. That means that in a scene with a combination of nanite and non-nanite geometry, it may take more time to
I enjoy
calculate the occlusion
coffee,
from the
tea
non-nanite
every once in a
geometry
while.
than it
I don't
does to
know.
just render
I'll
the
stick with coffee
non-nanite
for right now.
geometry occluded by
I need that
artificial
energy.
limitations.
But tea doesn't
Nanite
give me that kind of
geometry
energy.
also performs exceptionally well with the new virtual shadow map system because of this special occlusion and culling. However, since non-nanite geometry can only be occluded and culled at the instance level, the same large rock will be fully drawn, often multiple times if it touches multiple MIP or clip map levels, even if it only casts a shadow into 1 or 2 pages. Additionally, certain circumstances can cause a cache page to become invalidated, which means it'll be redrawn for that frame. This includes world position offset, even if it doesn't change every frame, pixel depth offset, deforming skeletal meshes, or moving static meshes. Consider, for example, a tree. In 5.0, it can be somewhat expensive to cast.
This culling
shadows
thing
from a
can be
tree
really
for
useful
three
for
reasons.
optimization.
Nanite doesn't yet support world
Yeah.
position offset and mask.
Oh, so
materials.
trees can't be. Okay, you just mentioned that, Sandra. It can't be mass materials, so trees can't be nanite.
Draw in virtual shadow maps. So a tree, which is not nanite and is constantly invalidating shadow cache pages, can cause significant performance issues. We can see that if we go to the view modes.
I mean, how do we optimize that then? What do we do for trees?
Cache pages. Each of these squares represents one cache page, and the green ones are valid and the red ones are invalid. As mentioned before, we fully intend to continue to improve the technology underlying Unreal Engine 5 in future releases and are aware of some of the existing limitations. For the time being, however, we have some controls to help you mitigate the performance impacts of things like foliage. Let's take a look at this simple scene in UE4. I have these trees spaced out every 1,000 units or so, and they're
you could do the trunk and nanite and leave and mask within wind can't work. Well, I would want wind to work.
Cascading shadow maps, which are the fully dynamic shadows cast into a series of cascades that cover the distance between the camera and the dynamic shadow distance movable on the directional light. Then, distance field shadows, which are static shadows cast against the distance field representation of the mesh. These cover the distance between the dynamic shadow distance movable and the distance field shadow distance. Finally, far cascades are dynamic shadows.
Yeah, doing wind, doing leaves and making them geometry. Fuck that. No.
Far cascades from the distance field shadow distance.
I think we can live with foliage not being nanite.
In Unreal Engine 5, we've got some similar concepts and added a new console variable to help as well. For non-nanite geometry, the different shadow stages look like this. From 0 to r.shadow.virtual.cache.max material position invalidation range, all shadows cast from potentially deforming non-nanite geometry, i.e. world position offset, pixel depth offset, skinning, etc., will cause the cache to be invalidated every frame. This means the shadows from things like trees will move and sway as the tree moves and sways. From the max material position invalidation range to the directional light's dynamic shadow distance movable, material effects will not invalidate the cache. So while the engine will cast shadows from the material, meaning you get nice dappled lighting through the leaves of the trees, the shadows of these objects may update unpredictably, or not at all, as the object animates.
I see. Okay.
Beyond the dynamic shadow distance movable, the virtual shadow map system will use the distance field representation of a mesh to cast shadows up to the distance field shadow distance. Beyond the distance field shadow distance, no shadows will be rendered from non-nanite geometry, with the exception of the following note. Anything that's set to far shadow will be rendered into the virtual shadow map out to the maximum virtual shadow map distance, regardless of dynamic or distance field shadow distances. Nanite geometry, however, will cast shadows into VSMs all the way out to the maximum VSM distance.
Yeah, this is some topics
The
I have a
cascade
lot of trouble
particle system from
understanding.
UE3 and UE4 is being deprecated from UE5. You will need to convert your existing cascade
I want to know how to do
as
this
soon as possible, as these will no longer be supported in a future version of Unreal Engine 5. To aid you in the process, we've created a Cascade to Niagara converter tool, which is
okay. So there is a converter
in your
tool.
project. While this is available in UE 427, we've made some major improvements to it that should help ensure a more accurate conversion in more cases. The converter is just one step in the process and only converts assets. It won't replace existing systems or components used in the world or blueprints. You'll also want to manually update Blueprint and C++ Cascade references to the Niagara particle systems to ensure they're working as you intend them to. Once the assets are converted, it's likely you'll need to modify the new Niagara system and emitters in the event that some feature of the effect was not properly converted.
Oh, shit.
Further, once you've converted the asset, we recommend making additional modifications to the emitters so that they're fully leveraging the power of Niagara. We understand that this process may be cumbersome and tedious, but we really think the effort is worth it for the additional power of Niagara as well as its performance benefits.
That's gonna be shitty. Luckily, I don't have that many particles or anything that I got from. Like, I also wonder if I wonder. Let's take a look real quick. Let's look at some of the stuff that I have. Like, for example, yeah, so like Dreamscape, like add to project. Is it supporting 5? I guess so. But like, I wonder, like, if I can like update some of these things, like the ones that have particles and stuff, like, are they automatically going to be Nanite? Not Nanite, Niagara. Or if I have to do it myself as well. So that's something I'm curious about. Maybe we can look at that in the near future. How are we doing on this? So yeah, we have 176 out of 5,841. So yeah, not too good so far. Let's jump back into the video.
Solution for large world management. The system
I think in UE5 Cascade is still there, and it's going to be deprecated and then eventually removed. So that, right, like, they're recommending that you move everything from Cascade to Niagara, because eventually they're removing Cascade. We can just check real quick. Will UE5 remove Cascade entirely? Let's see. UE5 Cascade is disappear. Cascade will be deprecated in UE 5.0 and removed in a later release. Alright, so they don't say exactly when, but it will eventually be removed.
Stores your world in a single persistent level separated into grid cells and provides you with an automatic streaming system to load and unload these cells based on distance from a streaming source. While world composition will load levels just fine in UE5, we recommend converting to world partition since we plan to deprecate world composition in the near future. For new large worlds, we of course recommend using world partition. Keep in mind that using world partition in a map will activate one file per actor, which will store actors in their own separate files in a managed repository within your content folder.
I don't know what that really means.
Source control contention with multiple users able to work in the same level without any issues. Currently, only Perforce is supported by one file per actor for source control, and we hope to add support for additional source control systems in future versions of the engine.
That's why I gotta use Perforce, baby.
World composition levels to world partition, as well as converting previously non-world composition levels to world partition. Before converting, keep in mind that any sublevels with level blueprints will be packaged into level instances, along with any references within that level blueprint. Additionally, during the conversion process, some references Particularly soft references between actors in any level may be lost.
Yeah, like if you were doing this like on an almost
You can
complete
convert a level
project,
from the tools,
going from
world
4 to
partition,
5, you would be
convert level
kind of
manually.
fucked.
This lets you
You would
select
have
the
to do
level
so
you wish
much
to convert,
things.
and you have the option to convert the level in place. Otherwise, a new UMAP file will be created which appends _WP to the end of your level name. Advanced users can customize the conversion commandlet and select that class from here. If you want to see what will occur during the conversion process without waiting for potentially lengthy source control operations, you can use the report only and verbose options to output a log of the conversion without actually creating any new assets. If any errors crop up during the conversion process, they'll be reported here, so you can address them before properly moving forward with the conversion.
Okay, so
The conversion
they're going
process
into
can
UE
take a bit of
5.
time.
After 2 years, they're going into 5 now. Oh my god. While you were there, did you notice a lot of significant problems when they're trying to do that conversion? Like, did they have a lot of issues trying to migrate particles from Cascade to Niagara? Did they have issues trying to migrate their lighting to use Lumen and Nanite and use meshes with Nanite? Or can you not say anything kind of specifically in regards to that?
And that depends on the size of the world and the number of actors. For the purposes of this video, I'll speed this up. We'll also include instructions in the resources below for advanced usage of the conversion tool, especially as it pertains to HLODs and source control. Once your conversion succeeds and you open your level, you may find that everything is missing. Don't panic.
Freak
This is
fuck
because
out.
the editor cells are unloaded by default. All you need to do to see
They
your
just
full
announced it
level
like on
again
Thursday,
is
so I haven't
open
seen the
World
UI.
Partition
Okay.
Editor.
I would
Select
assume
all the
that's going to be
cells,
problematic.
Click and hit load selected cells. The editor will remember which cells you have loaded and unloaded, so the next time you open the map, you won't have to do this. In the world settings for your map, you'll now see quite a few options in the world partition category. Here, you'll definitely want to set the default HLOD layer. This is an asset, and its associated settings will be used when building HLODs for your entire world partition level. And it can be helpful to have a default value in place which you can then override on a per actor basis. You'll need to run a commandlet to set up and build HLODs for your level, and we've included some helpful command prompt calls in the resources below to get you on the right path. For the time being, HLODs in world partition are only visible in play-in editor and cooked builds. One thing to keep in mind is that the Unreal Engine now ships with large world coordinates, meaning coordinates are now in double precision to support games of all sizes. Our goal is that this conversion should be seamless and
I mean, what was the whole what was that whole thing called? Floating point precision errors. Like, is that still a thing even with this world partition? Half the things disappearing would cause me to have a meltdown. Yeah, I would freak the fuck out, dude. I'd be like, what the fuck? I don't want to do this. I quit. My QA experience makes me shudder at the thought of conversion to a different version of the engine. I don't want to consider even moving from UE4 to UE5. Yeah, I mean, what kind of QA is that called? Like dev QA, where you're kind of working more with the tool side of the things and the editor side of things, most likely, instead of the actual gameplay. Yeah, it would be unfathomable to do that, like to start, to do a conversion that late into the project when you already have so much content created and maybe you had like significant code based changes and stuff like that. It's one thing to move from like 425 to 426 to 427, but yeah, to jump a full actual engine version that late in the project, they better have like a contingency plan because they're gonna be fucked.
require little to no changes to your content. In version 5.0, we can expect parity up to the float max limit for placed actors. However, there may be some instability beyond that value.
How far away is that fucking mountain?
Empower you to create very large-scale games, and you'll certainly be able to develop them in Unreal Engine 5.0. And we look forward to improving the precision of the system as we further develop the engine. As with many new features in the engine, we first needed to lay the foundation upon which we'll continue to build and improve. Of course, with new major versions of the engine,
okay, let's see what's
features of the
deprecated.
engine
Let's
that
see.
were deprecated in Unreal Engine 4 have now been removed from Unreal Engine 5. Firstly, tessellation has been completely removed from Unreal Engine 5 after it was deprecated in Unreal Engine 4.26. Dynamic GPU-driven tessellation is a powerful feature.
Do you remember when they released tessellation with Unreal Engine 4? That was a really interesting trailer. I want to watch that after this.
Incurred, which was, at the time, extremely limited. As the available hardware improved, memory became less of an issue, and instead GPU cycles have become more important. For the time being, where additional geometric detail is desired, we recommend you instead import the high-resolution geometry you need as
Just use Nanite.
For landscapes, we support high instance counts, so it's possible to author terrain as very high-resolution tiles. Look forward to some exciting developments in future versions of the engine here.
Nice.
We have removed support for gbuffer deferred decals in UE5.
I have no idea what the gbuffer deferred.
Once again,
I don't know what that is.
Foundation that will lead to some amazing new features coming in future versions of the engine. One of the most visible impacts of this change is the removal of the decal blend modes dropdown. Let's take a look at the decal blend modes as they were in UE4 to understand why. The engine now infers the debuffer blend mode based on the connected input pins. So let's remove those from the list. Then, emissive and ambient occlusion are special draw calls that blend either scene color or SSAO
Green space,
respectively, and
ambient
we can also
occlusion.
infer that information from the connected pins. This leaves us with alpha composite, translucent, and stain. Alpha composite and translucent are already an available selection in the main blend mode dropdown, so that becomes redundant. Finally, the stain blend mode is effectively a modulate type blend, and that's also a blend mode available in the main dropdown. So, when the engine converts UE4 decal domain materials to UE5, it will change the main blend mode dropdown to the appropriate mode based on the original decal blend mode and will infer the correct debuffer decal blend mode based on the connected input pins. As with any version upgrade, some issues may arise that are specific to your project, and there's a few ways and places you can look to find these issues.
Go to the community answer hub or something.
Use the build map check tool to highlight any issues in your map. This opens the message log, which is another great place to look for any issues. You can scan the output log. This has been moved to Windows output log, or you can access it from the bottom of the editor UI.
Yeah, I'm so glad they added that output log button. It was always kind of annoying to have to go to like the developer tools and shit.
Most importantly, you should package your project for your target platforms as soon as you've upgraded.
Oh yeah, we should do that too, yeah.
The errors and warnings that arise here will give you a very clear picture of any issues that could have occurred during conversion. We hope.
Okay, so we're gonna watch another video. We'll watch the guided tour. But I also want to watch that tessellation thing. So I think it's UDK or UE4 tessellation trailer. I forget what it's called. Yes, it was Unreal Engine 3, the Samaritan demo. I don't know if you guys remember this, but when this came out, when I was in college, man, everyone was shitting their pants, you know? It was like, oh, this looks so cool. Unlimited detail. But you know, you have all these like reflections on the light and everything. Was really cool. You have this shit, and you know, when you light the cigarette, you can see the smoke. It looks really cool, and that tessellates, I believe. Yeah, like all these like smoke wisps and stuff, like the detail on the rain, the sweat. He kind of looks like Nathan Drake a little bit. So basically, like this part that comes up when he changes his form into like a stone version, like this what's about to happen. You know, they should have done this for Gollum and Outriders. But yeah, that whole change was like, it's like tessellation and like the detail of everything. Yeah, this was Unreal Engine 3. fucking brains. Of course, you gotta smoke another cigarette. Yeah. All right, I'm gonna take a quick break. I'm gonna make my coffee. I'll be back in a second. I'll leave my camera on. Doesn't matter. I'll be back in just a few minutes. All right, your boy's back. All right. So let's see where we're at. So we're at 370 almost. So we got a lot of time. So let's watch the guided tour.
Unreal Engine 5 guided tour. In this video, I'll do my best to cover as many interesting aspects for newcomers as I can. Now, no time to waste, let's get started. As a quick heads up, I've already enabled a couple of plugins and project settings, and I call them out as I go through if you want to follow along. That's it. If you want to do them all at once, just check out the project description below. Let's begin with one of my favorite features that came in late during Unreal Engine 4, the Sky Atmosphere system. For those unfamiliar with it, the engine now has a full system in place for handling the sun, atmosphere, volumetric clouds, and fog. As a note, you can hold Ctrl L and move your cursor to easily reposition the sun. Let's create a blank map and create the system from scratch. I'm going to go File, New, and select an empty map. It's actually really easy to set up. All you need to do is open the Environment Light Mixer, and we actually have a button for each element necessary for a foundation.
Okay, what? There's a light mixer?
Pressing just one of them. Don't
I didn't know that.
Atmospheric light. It's not really needed for a conventional outdoor lighting setup. As I mentioned before, you can now use Ctrl L and the cursor to easily preview the
That's pretty wild.
to the position that you want it to be in. Now that we've got those in place, let's get going and have a creative space to actually play in. I'm going to use a tool called Cube Grid in the modeling tools to block out a simple space. Using Cube Grid is relatively easy. You draw out a grid, and you can hit Q or E to make it go up or down. You can also select a region and hold Control-click to drag it up and down.
Okay, I didn't know
By
about these
selecting a
tools either.
region
Holy
and
shit.
instead, you can actually go ahead and create ramps easily. And don't forget, you can always carve out into space. Lumen will kick in the second you click Complete on the model. For this space, I'm going to build one large room with 2 doorways.
I remember when you had to use like additive and additive and subtractive BSB tools to do this shit. This seems way quicker and easier, so.
You'll notice that from time to time I actually shift the grid up and down manually. I'm doing that with Shift E and Shift Q. You can also change the size of the grid with Control E and Control Q. Cool, so the space is crafted. First, let's make sure that our skylight, which represents the ambient light of the world, is fully dynamic. I'm going to enable real-time capture to do so. You'll notice that the room seems a little too foggy as well. That's because it's not really taking into account the light properly. Now, a cool feature that we have in Unreal is volumetric fog. If you go to your experience
nice.
of height fog, you can see a little checkbox for volumetric fog. By enabling that, we have this great look now where the fog is caught by the light as it comes into the room. I really kind of love it. With that in play, it's time for us to no longer use this checkerboard pattern and have something that's a little bit prettier. For this, I'm going to use Quixel Bridge. Now, a little while ago, Epic Games acquired an amazing company called Quixel and opened up their mega scans to all Unreal Engine developers for free within Unreal Engine projects. So, what does this mean? Well, if you open your content browser by pressing Control Space, you can right-click and click Add Quixel Content to launch Bridge. From here, I can search through the thousands of meshes and surfaces available to find something just right for what we're making. I'm going to grab this concrete and add it to my project. To do so, all I need to do is select the asset that I want, click Download, and then when it's downloaded, click Add. I can then just drag in the instance.
It's pretty wild.
See that it's a little bit too tiled, so I'm going to go ahead and change the tiling in the material instance. Now, it doesn't have to just be surfaces though. I can add decals, which project onto surfaces, as well as static meshes too. I'm going to set up a scene with this rocky ground, a tree, and a fireplace. Want to know something cool? Well, each of these rock meshes on the ground that I'm adding is actually over 1 million polys. And this highlights one amazing feature of Unreal Engine 5 that I've casually gone and implemented here, which is Nanite. Now, Nanite is Unreal Engine 5's virtualized geometry system, and it allows you to create super high quality meshes, often ones that don't even have to have normal maps, and import them into your scenes. You can instance them again and again, and the performance against traditional meshing is really quite incredible. One aspect of Nanite meshes that I love is that due to the density, they can actually blend together really nicely.
That's true.
These two meshes would have likely had some Z fading on the surface. However, in this scenario, the little bumps and imperfections make them blend together quite well. Another thing that I really like is that decals work wonderfully with Nanite too. So I'm going to super quickly create a puddle decal material and apply that. This is literally just going to be a radial gradient with some noise around the edges to create a puddle-like visual. Now, don't worry about having to replicate this yourself. You can always copy this graph, or you could import a decal from within Quixel Bridge. But anyway, as you can see, decals work really well with Nanite meshes, since the mesh data helps break it up a lot and actually informs the height values that are there. In case you're wondering about how they behave on older consoles or mobile, don't stress. Under the hood, we actually automatically generate a Nanite fallback mesh that has a more traditional poly count, and this mesh will get loaded instead of the other one on those older systems without having to manually fiddle with it. That said, you can fiddle with it and change the approximation values if you want to dial it.
I mean, would that then cause Z-fighting on consoles or something?
I've been kind of overlooking something. You know how from the moment I created this environment, the light just accurately bounced around? That's Lumen. Lumen is the default global illumination and reflection system in Unreal Engine 5. It renders diffuse interreflection with infinite bounces and indirect specular reflections in large, detailed environments at scales ranging from millimeters to kilometers. I like it because, honestly, it just means light behaves like I'd want it to. I don't have to set up fake bounces, and beyond all that, it presents a nice unified pipeline for lighting, which, as a developer, makes me incredibly happy. Now, first off, that means that elements like source radius and source length on your point lights create more realistic lighting representations. See how the edges here get softer? It's subtle, but it really contributes a lot to your scene. Now, I want to go ahead and test something else with Lumen, but to do it, we're going to need another room. So I'm quickly just going to add a doorway here and a second room, and we'll go into that, because if I go and I add a sphere to the scene,
Oh, it's gonna do like a
I
emissive
go through
material.
and I create a really straightforward
Yeah.
emissive material and apply it to that sphere. We see something kind of cool, and that is that, yep, emissive contributes to the lumen representation. Now what this means
Yeah, that's really
is
cool.
that little lights in your scenes that are part of your meshes now help actually light the environment. As we move away from this sphere, we can see the light disappear though, so we need to go ahead and investigate this. Now, here's where it's important to look at a new tool for analyzing your lumen representation. Simply go to View Modes and select Lumen Overview. You can see what's being represented by lumen here. Now, if this is a problem, you can simply drop into post-processing volume and increase the lumen scene detail. I'm going to begin by going ahead and actually setting the post-process to have an infinite extent though. Now, a post-processing volume changes what your screen sees after the core image has been rendered. In this situation, it says, hey, don't actually constrict these options to just be what's inside the volume,
Yeah.
but rather
The editing
let
of these
everything
videos
else
are
in the
really
work.
good.
This means this is kind of like the default post-process now, and other volumes would override it. You can see here that as I've changed this to override the scene detail, that now that light is being correctly included, which means everything is pretty much how I want it to be. In case you're wondering, this essentially just changes the minimum size of objects that are getting picked up at various distances, so they get culled appropriately.
How do you feel about the new layout?
Now, often the values that are there as default work
I mean, it's more or less,
but
it feels the
sometimes you
same.
need to tinker with them.
Like like
While
I
I'm
mentioned kind of
here,
before,
I'm gonna go ahead.
it's nice to have like the output log at the bottom. The content drawer is kind of weird. I never used content browsers in the same way as other people. I always like to keep it as a separate window tab instead of it being like docked in the viewport or anything like that. I just felt that it was much easier for me to have it because like I don't work much with the actual level editing stuff. You know, I'm not a level designer or anything. I'm more just tools and orientation and stuff like that. So seldom how I would ever need to like have quick access to the content browser, drag and drop things a bunch of times. I do appreciate the like the level tools that they have that he was showing, like the cube mode, whatever they use to build this stuff. You know, the general darker light feeling of it is nice. Like obviously it's better for the eyes. I think you can customize it as much as you want inside the editor preferences. There's just, you know, there's a lot of little nooks and crannies of Unreal 5 that you kind of have to find out based on what you need. Like I said, all those different modes that exist, I had no idea any of them existed until I started watching these videos. So that's kind of good to know. How are we doing on this? So we're almost at 500, so that means we're almost 1/10 of the way. So we can continue watching.
Ahead and fix a couple of other post-processing things. I'm gonna go stir crazy if I don't fix up the bloom just a little bit and the exposure levels so that they're a little less harsh for the kind of scene that we're building. Dialing this in, I think, is going to be important for, you know, making sure everything looks good for the rest of this presentation. So now that that's up and running, what's up next? Niagara. Niagara is Unreal Engine's next generation VFX system, and it's been around since reasonably late in UE4's lifecycle. There are some new toys for it packed in with UE5 though. So I'm going to go ahead and create something basic to begin with. I'm going to create something that's based on a fountain system, and then we're going to go ahead and we're going to modify it as appropriate. I'm going to call this ns_sci-fi particles. Inside of Niagara, we can see that we have our fountain emitter.
Can I get better quality
See
here?
we have a few different sections.
There we go.
Particle spawn is responsible for what happens when a particle is created. Update for whenever that particle is ticking over. Emitter update is what happens as the emitter itself is updating. Let's increase the spawn rate to see what that does. Now we can see that that's creating more particles. I could, for instance, change it so that we have less gravity on every update. So I've set that to -20. If I was to delete the initial add velocity, we can see those particles aren't moving when they're first spawned. I'm going to increase the shape location here to 250.
Okay, so you're going to create dust?
But we can see the particles aren't distributed.
Yeah, sci-fi particles. Yeah, it's going to be like dust.
We can fix that by setting this surface distribution value to 1. Now, we have something that's looking a bit nicer, a little bit more sci-fi, but let's go on from here. In my particle update, I'm going to add a curl noise. Curl noise is great because it's kind of like random noise. And if I set a value to 1500,
Oh, Jesus Christ.
we get something that's a little bit more sci-fi. However, I actually want to process this before we add drag, because by setting the drag values to 6, it's now slowing down after it adds that.
That's pretty
pose, which
wild.
gets
Like,
us
this
that
looks so
shiny,
much
sci-fi
easier
look.
than Cascade.
Let's go ahead and get
I don't
some
know
more
why.
particles. I'm going to go and change this from a CPU emitter to a GPU emitter in the emitter's properties. The reason I'm doing this is because I can now have way more. Whenever you create a GPU emitter, you need to set the bounds to be static. Let's see what that big number looks like. That's a bit nicer.
What the
With
fuck?
this in place, I'm now going to
That's so
start to
much.
dial in the colors. Let's get something a little bit more goldy, just to match the sphere that we have inside the world already. By default, every particle is always facing you. A cool thing that we can do is set the alignment of these particles so that they actually
Man, these tools seem
go
wild.
in the velocity direction. So as the particle moves through space, it's kind of stretching along that way. This means that I can go down to the bottom to the sprite render.
Honestly, there's like
and change
thousands
the
of things that you can do, and like trying to do this
If
by
I
yourself for the
come back
first time, it
my
has to be very
properties, I can see that it's possible
intimidating.
to actually set the initial size to be different on the X and Y axes. Let's take a look at how that goes. I think that's giving us something that feels a bit more like sparks, which is really what we want for the sci-fi effect. Let's take a quick look at that in the world. I'd say this holds up pretty well. We've really got that sci-fi look, so I think we can move on from here. Because it's cool, but we've all seen particles before. But one new thing in Unreal's bag of tricks is the addition of the Niagara Fluids plugin. Let's go ahead and create a new emitter based on the fire example that we have here. I'm going to call this NS Campfire. Now, if I go ahead and I create this effect, I want you to take a look at it in the world. Notice anything kind of different about it? Let's put it in slow motion. That's right, it's volumetric.
Okay,
Now,
volumetric,
I
okay.
really love this. And I'm just going to say, look, I'm not going to go into it fully here because we just don't have the time.
That's why I'm intimidated by it. There is an endless amount of options. Cascade was rather limited and easier to wrap your head around.
Particles
I suppose so. You know, you kind of have to just fuck around and find out, kind of thing.
On that. There are additional examples in the plugin for explosions, water, and more too. So if you're a VFX artist looking to level up, I highly recommend you check them out because I think they're really exciting. Just don't forget to disable the overlays when you've put one in the world, otherwise you'll end up with that red box. Now, speaking of volumetrics, another late UE4 feature that has been enhanced by Lumen is...
Actually, I feel that Unity tools feel more complicated, not due to being actually more complex, but due to a less intuitive UI. Yeah, UI definitely. UI, UX,
now, in UE5,
game changers, obviously.
The volume domain, which allows you to inject...
And like with Unreal, you know, all their tools are more, or now their tools are very what's the word? They all work and look the same, kind of. They all function in similar ways. Like the Cascade editor is so significantly different than the Blueprint editor and the Material editor, and now Niagara has that similar Blueprint Material vibe. So it's, I don't know, more intuitive that way. You're not having to like kind of re-grasp how to edit some things.
And set that as the extinction on a material. I've also gone ahead and I've set the albedo to a value of 1, which means we'll have white fog coming in. Now, when this has been compiled and applied to a material, it actually creates a volumetric fog mesh. It's cool, right? Like, it really adds something to the scene. Now, we can also go ahead and we can tinker this a little bit, because it's nice like this, but if we want, we can subtract some noise from a volume texture, much like we did with the decal, but in 3D. So this will create a more smoky look. Again, like, don't stress if you can't just whip up one of these materials on the spot. I'm doing my best to kind of freeze frame on some of these shots, but in addition to this, we'll do our best to get some tutorials up in the near future for the community to access more readily. Finally, if we add panning to the Z-axis, we can actually create smoke that slowly moves up over time. Now, the great thing about this kind of fog is that it's really...
Yeah, that's a great design when they can use similar UX structures for various tools. Yeah, 100%.
It really just helps bring a scene to life. And I strongly recommend any tech artists out there and VFX artists to consider this approach in their scenes. Because at the end of the day, you know, even though there's panning and volumetric noise in this, you can do a lot more. You know, as a tech artist, you could easily see how close the smoke is to the nearest surface to react differently. Or you could use custom primitive data to have a per fog
That's a lot of fucking smoke.
Before we go outside, I want to quickly add some music in the other room for a bit of a vibe. Here I'm going to leverage UE5's meta sounds to create
Yeah,
some
meta
cool
sounds a whole new
ambience,
thing as well.
room. Now, while what I'm about to do
On the
is
topic of elements,
essentially
it's a
make
great
a
resource
synth,
for
I wanted to
optimization.
show you you
It can make it
full
almost
audio using
free.
meta sounds, and I strongly recommend checking it out. To begin with, I'm going to go ahead and I'm create a sine node. Now, this
Nice.
just takes a frequency and then it plays that frequency. I'm gonna set it to 200.
And yeah, now you have the audio tools. Audio tools was always looking like blueprints as well. So
Alright,
again,
it's not exactly Mozart, but the cool
it's
thing
nice.
is we can get that frequency and we can actually set it to play something based on a given MIDI node. So here you can see that I've added a MIDI node quantizer on a.
Honestly, I have no idea what he's doing. I'm not an audio designer by any stretch of the imagination.
That's cool. Now, instead of me mashing the play button, how about I put in a trigger repeat and set it to a given BPM? Cool. So how about we actually make that volume drop off? I'm going to add an envelope. This means that whenever it plays the note, it kind of fades away as the note plays.
Yeah, how to make a creepy sci-fi theme song.
How about we grab all of this and we play it over the top of itself? Another thing I can do is I can look at the currently playing note up above and I can find another note that's pretty close to it by just getting that value and adding an offset random instead of something that's specifically set to be in the range. That way it's always a little bit closer to the note that I'm currently playing. Cool, and we can change how frequently those other notes play.
That sounds so fucking weird. Just computer generated music.
See how easy that was? I really love doing this. Let's go ahead and put that into the world. Okay, so I'm going to just drag this in. But it's also a good idea for me to set up a little bit of attenuation. So I'm just going to override the attenuation so that it just fades off as we move away from it.
That's cool. Like audio design is so
The most
wild.
relaxing part of this video. It's time for us to pick up the pace again, go outside, and build.
Let's just check in on our compilation. So we're at 700 now. Sci-fi Minecraft vibes. Yeah.
An environment. To begin with, I think we should probably rough out a bit of a shell for these buildings to keep marketing off my back. Once again, I'm just going to open up CubeGrid and whip something up. So this will kind of just add a little bit of detail. We don't just have a single box in our environment. But with this done, I think it's a good idea for me to go
I guess the compiling will end in a few hours. Probably.
A landscape.
Nah, but I want to stream the whole time. Just have like a nice little marathon of streaming and watching all stuff Unreal Engine, you know?
And landmass plugins. To begin with, we're just going to create a landscape from the landscape mode panel. Make sure you have enable edit layers checked or these plugins won't work. Now we can see that this is in play, and if I wanted to, I could just paint and sculpt straight into.
Is it gonna just use a height map?
Cooler than that. We're going to go ahead and we're going to add a blueprint brush to our scene.
Oh, you can make a blueprint brush? Whoa.
You'll see that when I add this, it adds 3 little dots connected with some lines. And that's because landmass lets me actually paint into the world with splines.
Aha.
In addition to letting you paint with splines, we have a bunch of other options. For instance, we can cap the shape, we can add curl noise, we can add displacement, and all of this compiles to kind of create
That's wild.
a much more realistic but easy to iterate upon environment. Also be aware that you can stack multiple land masses on top of one another to kind of create.
I think me and Christoph were talking about this yesterday.
I'm not going to do that here. But for the next step of what I'd like to do, I'm going to go ahead and I'm going to go back to my standard select mode.
Is he just going to make an
I'm
island?
just going to drop in an ocean. Now, the water systems in Unreal are actually pretty straightforward. You can drop in oceans, lakes, and rivers, and the materials
Similar to the
actually
large bowl, I
programmed
think.
to,
Okay.
combine information so that rivers will correctly flow into oceans and, lakes into rivers, etc., etc. It's actually a really exciting system to have, and it being able to manipulate the landscape beneath it is really, really cool. Plus, there's a bunch of properties that you can work with to change things, such as how steep the beach layers are and how the fall off looks. I really love this for getting a scene up and running quickly. And as before, there's just
Yeah, maybe my
easy iteration
test
in
area
Migrate.
should be like a small island, so we can have like water
mistakes that have
looking around it.
require a
Maybe we can
special
test
personal touch.
swimming. Maybe we
You
would
can
want to
create an
implement
additional paint
swimming.
layer, and you can just paint those out. So this adds something on top that'll say, hey, subtract this area and sculpt it out. And this means that we can keep it, both procedural, but still have the custom touches that are required to get the visuals that we're after. Speaking of the visuals that we're after, let's go back to Quixel. I'm going to grab 3 sands and some beach rocks and a concrete bollard that might help, imply that there was a pier at some stage or
That
something.
would be cool, or a boat.
So let's go ahead.
But yeah,
and
boat.
bring
Oh man, that would be really difficult.
with those
But maybe
in,
we can have like
let's start
rafts
to
and
set up
stuff.
a landscape material that we can use.
Kind of like Breath of the Wild style. We can use like the left leap, and you blow, and it's like a physically based boat or something.
And now, while we could plug them in like we normally would, it's worth noting that Unreal lets you create materials inside of materials in a way. And it does this through the material attributes type. And once we do that, we can actually blend them together. And this is a really great way to make landscapes. You just need to make sure you have the use material attributes boolean checked in the properties of the material. Once this is done, you can go ahead and use a set material attributes property to kind of actually just plug them in the same way you would if this was the standard output. Now, by doing it this way, we have kind of created like a little mini material that runs through a single wire at the end here.
Yeah, boat sounds complex. Have you worked with like character to vehicle movement? No, I've never really done that.
The cool thing here is that when we add a landscape,
I mean, like for my kind of project, I don't know. Like boats would make sense, but like any other vehicle, I don't know. Maybe you can have some sort of like magical vehicle or something. Even Breath of the Wild was like they implemented a motorcycle thing in their DLC.
I just need to apply.
Would that work via possession? Yeah.
Add
Well, yeah, if it were to be like an explicit like car, so like for example, if you have
now it's tiling a bit
if you have a like GTA style, right? You have planes and cars and motorcycles, whatever. Like the vehicle would be, I believe, the pawn with its own controller, and then when you possess this pawn, your controllers change, your mappings change, how the actual control of the pawn would change. So yeah, it would be like that. What the heck are these plugins? UE6 trailer. Hey, we've used properties of quantum computing to generate reality with all the. Yeah, we're using Unreal Engine 6 for the metaverse, so we're good.
Now, with that locked away, it's time for us to use the foliage tool. So just go into the foliage mode and drag in the mesh that you want to use. In this case, I'm going to use the Thai beach rocks. And I suggest lowering the height offset and using an average normal. This means that when we paint them in, they'll stick into the ground a little bit more, and they won't be as drastically attached to the ground's direction. Now by doing this, we can then just hold down click or shift click to just paint the rocks into the world. And this is going to work reasonably nicely for setting up our scenes. It's worth noting that each of these is a nanite mesh, and I'm painting in like 1,000 of them, and the computer doesn't really flinch. I'm also going to use this
to
kind of go through and start to paint out the wet sand around the rim of the island. And after I kind of paint in that wet sand, I think it'd be a really good idea for me to go through and kind of smooth that out somewhat, just so that we end up with a slightly more natural gradient leading into it. I could spend a lot more time on this and adding many more landscape layers.
You plug into your computer, you think about it, and then you're done.
In addition to the Thai rock, I'm also going to paint in a little bit more foliage, which will be some thatching grass, which is from Quixel as well. I'm going to make sure I scale this up so that it doesn't quite look as nasty as that first one did. I think that was intended to be a little bit denser. But just getting in some thatching grass will really kind of break this scene up quite nicely. I think this is going to
I'm really curious what the end result of this level is going to be.
So this is all well and good, but I still have an issue with the scene, which is one last thing I'd really love to fix, which is, when stuff touches the sand, it just kind of sticks into it. It doesn't blend or anything. Well, we can fix that. And we can fix that with a concept called a runtime virtual texture. Now, a runtime virtual texture lets you dynamically capture certain objects to a texture called a virtual texture. Now, this is really, really useful because it means you can then blend that material
That's wild.
into any object in the scene. So in this case, we're going to capture two RVTs, the environment material and the height of the landscape. RVTs require a bit of a checklist to implement, but once they're in, and anything can use.
So create a runtime virtual texture assets, create runtime virtual texture bounds volume. Okay, it's hard reading.
Runtime virtual texture assets. We're going to call one RVT underscore environment and another RVT underscore height. Make sure you open up the height RVT and set the value to height. Now, that's step one. Step two means creating a bounds volume and setting it to be the size of the landscape and setting the RVT onto that one. You'll need to do it twice, once for each of the runtime virtual texture volumes. So just drop in a runtime virtual texture volume and then set those values.
I mean, those patches of rocks kind of look weird.
Changing the landscape material. We now need to set up a new output node that is to tell it, hey, when someone uses a runtime virtual texture on you, this is what to output. There's a couple of gotchas here, but you should be able to run all of the pins across as required, except for the normal. The normal you'll need to translate into world space by adding a transform vector and go from tangent to world space. And to get the world height, you'll need to get the world position and then only get the B channel, which refers to the Z axis. Again, don't stress too much if this is a little bit above your head. You only really need to do it once, and you can copy it from this video or our online tutorials. Now, the final step in setting them up is to simply assign those two RVTs on the landscape itself, which says, hey, you're contributing to the runtime virtual textures.
Wow.
Now, with that all set up, you're ready to set up the blend on the material itself. So to get this part going, what we need to do is open the parent material for the Quixel asset. Once we've opened this up, we're going to start setting up a blend. To make things a little easier to understand, I'm going to do the blend first and just blend it to the color red. Now, to get that set up, I'm going to use the blend material attributes node that we used in the landscape material earlier. And I'm going to set.
So I'm curious what this what's going to be.
A red color.
So like, are the actual blends between the two assets, is that going to be turning red? Is that what this is going to be showing?
It's the pains of having a slightly more complicated setup, but the rest of it is easier because of it. So we're going to add a runtime virtual texture sample and set that to be the world height. After we have that in place, I'm going to go ahead and I'm going to compare it to the world height that we have of the current object. So it says, hey, let's look at my height and subtract the world height of the landscape. If it's a positive value, we're above it. If it's negative, we're below it.
Oh, red is a coordinate, okay.
We can see that, we can blend by 10, for instance. It'll say, hey, when we're 10 centimeters away, that's a full blend away from it. Let's take a look at that.
So yeah, that's what I was thinking. That's what I thought.
It's touching, and it's
the
rest of it. So it's actually picking up where the ground is.
Mm-hmm.
Let's go ahead and remove the set material attributes node and instead set up the runtime virtual texture setup that we want to have. So I'm going to do another runtime virtual texture sample, this time sampling the environment texture, and I'm just going to plug these values in. And when I plug these values in, we're going to be able to set this up.
God, there's so much involved with this. Holy shit.
Be aware that the same way that you passed the normal from tangent to...
But it's really cool.
before, you now need to get that same normal and convert it back from world space to tangent space. So with world to tangent set up, that will now correctly blend in the angles of your material too. So I'm just going to delete that material attributes node and click apply. Back in the world.
Okay.
You can see that any of these objects, when they touch the sand, will automatically blend in. Even if we paint something under
That's so
it
cool.
will now get the newly painted material instead. And we can try this on all sorts of assets. So let's kind of drop something in. Let's drop in those bollards that I mentioned before. We can see here that they're comfortably blending in. It's a good idea for us to tinker with a couple of other assets too. But if I get something like this bollard and I kind of handle this blend, I can get some really, really nice looks. And it's great because, as I said before, once you do this in something like the base Quixel,
Yeah, I mean that's really cool. Because like,
just going to behave like
you don't need to manually paint this kind of shit. It can just happen.
Everything kind of suits the world a little bit more, and It's a really, really great technique that we've been pushing pretty heavily, and I'm super excited to show this to folks every time. Now, one thing I really want to touch on as well in this video is just a reminder that we're always giving out free content on the marketplace, and that free content is if it worked in UE4, there's an incredibly high chance that it works in UE5 as well. One of the perks of Epic making games is that we've really had to push some pretty aggressive backwards compatibility for a lot of our concepts. So by having something like this, I can go ahead and I can just drop in UE4 boats pack that was made for Twinmotion, and I can put them into the scene. I can use that as a nice way to decorate things up. But I really just wanted to stress it because it's very easy
That's a
for
small
folks to think,
canoe.
well, 5 is one more, therefore none of the stuff from 4 is compatible. But a lot of it actually still works, and it's exciting to use. So
I wonder how
last
you would be able to
session,
get like those boats to like
I'll
bounce
admit
with the
I forgot
waves.
something earlier. I'm going to bring in a tentacle from the Kraken asset on the marketplace. Now, I've limited it to just the tentacle to just cut some time out of this presentation and to, not spend too much time rigging up an entire creature. But we're going to go ahead and we're going to create a control rig for this asset. Now, control rig is a node-based rigging system. It's designed to provide riggers and animators with tools to create flexible, dynamic, and procedural characters with artist-friendly interfaces. Unlike Blueprint, Control Rig uses its own lighter weight VM called RigVM to provide highly efficient pose calculations. So in this scenario, we're going to set up 2 simple controls for this tentacle, and then create an animation for it. To create a control
Border
rig,
here has a
simply
buoyancy, I think.
right-click
Yeah.
on the existing mesh
Okay.
and click Create Control Rig. We're going to create our first control rig now. To begin with, I want to point the tentacle in a given direction. So I'm going to go ahead and I'm going to call Set Rotation. Now, we need to tell it which of these bones is the parent for the rest of the rotation. So I'm going to call Tentacle 1. You can see that it's rotating. We need to inform this, though, a direction to rotate. So I'm going to create a new control. And we're going to use this new control, which I'm going to call Base Rotation Control, as a way of directing this. Now, to do so, I just need to drag it into the graph and click Get Control. You'll notice that you can't just connect transform to the rotation. You need to actually drop down and get the rotation to connect.
I've never seen this kind of tool before.
And there, with that connected, we now have something that's actually functional. So we can see that that rotation is now modifying the tentacle, which is what we want. However, when I hit compile, it resets. That's because you need to get the control and tell it that its current transform is the default. So you actually, by hitting compile there, it's now going to show us that it's always defaulting to that position.
So this is the control rig. It's a control rig actor, I guess. It's from the control rig class.
IK node. Now, full body IK is a bit of an advanced node to use for this one little tentacle. But a cool feature of it is that it's able to have multiple effectors. So you could actually use this full body IK node to drive an entire Kraken. Now the full body IK node needs to know some stuff. It needs to know what the root is, which in this case is just the root. It also needs to have some sort of effector, which tells it what to reach towards. I'm going to tell it that tentacle 15 is reaching towards a position. By default, it's going to be 0, so it's crushing in on itself. So let's create a new control that I'm going to call Reach Control. Now, Reach Control, we're going to drag in and we're going to set it up. And we're going to connect the transform to our...
Okay, so now it's going to try to get...
You'll notice that when I drag it up, it's kind of working, but we're getting some kind of strange behavior. That's because full body IK can be a bit of a strange one when reacting to large chains.
Thanks for stopping by, man. I appreciate it. See you around.
Increase the mass. And that'll give me a more realistic...
Is there something this guy doesn't know how to do? Audio? Yeah, I mean, like, I don't know who this guy is. He's like, I think he's an Unreal Engine 4 evangelist, I believe. His name's Chris Murphy. Let's see what he is on LinkedIn. We can double check this. Chris Murphy, Unreal Engine. Maybe he's not on LinkedIn. All right, let's keep watching.
See that it's folding in on itself.
Actually, let's double check. Okay, we're at 1,200. So we're more than a fifth of the way done. Like eventually, it's gonna go by pretty quickly. There's some more heavier things that need to be compiled, so we're definitely not gonna be here all day.
And there's a little bit of a bob going on there. So let's fix these.
Okay, that's him. Okay.
Set the initial offset from the current.
Very nice
as
find.
we had before. However, you'll notice that there's a little bit of a rotation and it's 90 degrees off. So we're going to correct that too, and once again, set offset transform from current. Of course, there was one other little issue that we were facing, which is if I pull it up, it disconnects. So in this case, I'm going to set the root behavior to be pinned to the input, at which point the tentacle is now staying where it should, and we're able to have simple controls to guide what it's doing. This is really, really useful, but those controls are hard to see, so let's go ahead and fix those. I'm going to select Reach Control, and I'm going to set it to be a scale of 8. And you can now see that it's a big red ball, which is great.
Okay.
It gives me something to guide it with. I'm also going to go to Base Rotation Control, and I'm going to set it to be a size of 8 as well. However, this is it's probably best for us to have something that's a bit easier to see. So I'm going to go ahead and I'm going to set this to be a thick wedge, which gives us a shape, which is a little bit easier for working out which way that control is pointing. Fantastic.
Interesting. Okay.
Let's go ahead and apply this to the world. When you go to drop a control rig in the world, it actually goes ahead and sets some controls up for you, which is great. So if I go back to my content browser and I drag the control rig into the world, we can see when I let go that it actually loads up Sequencer. And the cool part of this is that I can use Unreal Engine's Sequencer to actually rig what this animation is going to do. And that's really powerful because I can kind of set these bone directions up, I can tell them which way to face, and I can keyframe it using the tools that we're already familiar with for all of our standard cinematics. And in this situation, I'm just going to drop it in there, and I'm going to go ahead and add keyframes to both of those controls to kind of get something that looks a little bit wiggly and menacing over the island. It's a good idea to grab those two initial keyframes and alt drag them to the other side as well, so that we're starting and ending at the same location. In this situation though, I'm just gonna kind of get something that I think will work. And with this kind of what we're gonna go ahead and do now
That's cool.
is we're gonna create a linked animation. So a cool thing here is that if you right click, you can actually go create linked animation sequence. And what this does is this actually saves out what you've just done as an animation that you can use in the conventional Unreal Engine pipeline. In my situation, I'm just going to save it out as an idle animation, and then I'm going to set the animation mode to be playing an animation. And when I do that reset, I'm just going to flag that it will kind of reset the values, because I set the transform in the sequencer, so it did kind of get small again. But again, that's really easy for me to fix. And let's take a look at what that does when it's got another one with it as well. Great. So this is kind of a weird demo. We now have an island that we've created pretty much from scratch with some wiggly tentacles going on, again, that we created the animations for. We've got landscape blending, we've gone through Niagara, we've gone through Lumen, we've gone through Nanite, we've gone through Control Rig.
Yeah, you went through a lot of shit.
Through water. So there's a lot here in UE5, and I'm super excited for what's here in 5.0, let alone what the future will bring. I hope this session has been really useful for everybody. Thank you very much for your time. My name is Chris Murphy, and this has been a pleasure.
Okay, what should we watch next? See what there is. I guess your first game in UE5. This might be worth our time. Again, we're at almost 1300.
My name is Andreas, and in this video I will show you how to start creating a small game from scratch in Unreal Engine 5. We will use some of the latest features, but also established workflows from previous versions.
We will build a small top-down game and import.
I don't understand, like, people at work, I'm away, I have vacation, and they still decide to message me on Slack.
Build a small interactive system.
It's like, give me a break.
A little bit of polish at the end. So let's start by creating a new project. When you open Unreal Engine 5, it presents you with the new templates you can start with. So they contain new mannequin, Manny and Quinn. But in our case, we will start with a blank project and just call that first game. Everything we are building here, I do.
Yeah, I'm so upset they don't have side scroller as a default project type.
Sure, it's recorded
or a project template.
to create a better flow so you can follow. I'm using the assets from a SteckoBot sample project you can download from the marketplace. So here we are, and when you have the project open the first time, you can see this new map here, which is already set to word partition and has a pretty nice real-time lighting setup. But in our case, let's start a new map, and we don't use the existing ones, but we just do a completely empty level.
There was one in UE4, yes, there was. But right now, from what I know, there isn't one. For example, like we double check that right now. So let's launch this. I'm pretty sure they don't. If they do, that's nice, but I don't think they do.
Listing all things of our.
Oh, okay, I am right. Cool.
The details of what we have selected.
Yeah.
Up here are different modes. Like
No side scroller. Wah wah.
Spoilers that we can use later. This is the create menu with all kinds of actors we can place, and the green button starts your game. The view modes and show flags allow us to investigate our scene. Down here is a content drawer with a folder structure of our game that you can also open up with control space in all editors. With F10 you can toggle the sidebar. Let's bring in our first actor. We could navigate through the menu.
I need to open a window. It's getting hot in here. I'll be right back.
Here it is, even if we can't see it. It's in the outliner, and also in the details panel you see the properties. When we switch the view mode to unlit, we can see it there. So let's make some light. We will use the environmental light mixer to fastly set up some lights. By creating directional light, you can now begin to see the sphere.
Much better.
Change the values, like the
Finally getting warm.
Control L. We can change the angle of our light so it comes a little bit from the front. This is real-time lighting by default. In the project settings, under rendering, you can find the settings. New projects use the new global illumination system, Lumen. So let's add some more. An atmospheric skyline, a sky and atmosphere, the new volumetric clouds, and a height fog. We also want our atmosphere.
You pretty much need to click on every single thing. You're just like, I want this, I want that, I want that.
Skylight. The actors got all spawned at 000 in the world and are a bit hidden. So let's line them up a bit so we have a cleaner scene and don't lose the overview. What we also can do is creating folders in the outliner and move our actors for the light setup in there. Projects can very fast get very messy, and some housekeeping from the start can go a long way. Next, let's save our map. Again, let's keep it clean, so we want to do a new folder calling it maps and save our map as Valley. When we now take a look in the content drawer, you find this folder structure. Now we want to bring in
First
our
asset time.
asset. In the content drawer, we will create a new folder and call it props. That will contain our meshes, materials, and textures. Pressing import, let me choose an asset I want to bring into the engine.
Of course, there's going to be a crate.
That was created in Blender, but you can use any DCC tool or get.
There's actually, I forget where this litmus test came from, but there was some level design litmus test where, like, at the time it took to find a crate in a level. See if I can find that. Level design crate litmus test. I don't know how to spell litmus. Level design crate test. Huh. I'm trying to remember what it's called. Yeah, wooden grate test. Let's see, level design. How long it takes to find crate. I read this somewhere. But yeah, basically that was like, you know, if like a reviewer basically reviewed a game and scored it based on how long it took to find a crate, because you know they use crates for level design just to fill in as props and shit, at least back in the day. And so I thought it was called like the crate test or something. And it's like, you know, it took like 5 minutes to find a crate or something. It's like, this game sucks.
Let's dock it up here. On the upper left, you find some numbers about the mesh, and the details contain 3 material slots. This button leads to the location of the asset. Let's open the material editor. On the upper left is a preview. Below are details. Most space takes a material graph where we find this big output node where we can connect nodes to. For example, this one is color we can change. When we hit apply, we can see the result on our mesh. We can zoom in a bit to see how the material is looking from different angles. Let's go back and improve this a bit. When holding 1 and doing a left click, you can create a node with 1 value. We can connect this to roughness of the material, and the
now it's
is
shiny.
immediately updated. Hit apply again to see how this glossiness looks on the crate. Let's make it more interesting by importing textures. So we can import 2 textures here, grayscale grunge texture and a normal. So once this is imported, we will find it in the content drawer and can drag in the normal and connect that to the output pin. So when we zoom in a bit, we see this nice little bumps here on this material, which we can also witness on the crate if we want. So let's go back and do one last touch until this plastic is done. Let's bring in the grunge texture, and instead of using a fixed value, we use this for the roughness, which gives us this look that it's a little bit touched, which is quite nice. So here we go. This is our plastic material. So let's go to the next one. So next up is metal. Let's open up this material, and the first thing we want to do is changing the color a little bit. So let's double click here and make that a little bit lighter. Next, we hold 1 again and left click to create a scalar and put that into metallic and change that to 1. Now we have a metal ball. So we do this again now with 0 for the roughness, so we have this really shiny thing.
Wow.
Let's take a look how that looks like.
That's too much, I think. Yeah.
That's nice. So again, let's make this a little bit more interesting by including some textures we prepared. So we go here and we have a normal again and a roughness. But we will do something slightly different. This time again, we drop in the normal and connect that to the normal output. But if we take a look at that ball, it's a little bit too noisy for our taste here. So we do a right click and then we look for something called texture coordinates, which gives us access to the UV tiling. So when we connect that to the UVs and then changing the values to, for example, 5 and 5, we will get something that's more desirable. That's nice. So let's take a look how that looks on our crate. That's cool. So let's go to the roughness again, and this time we will bring in the texture we prepared, but instead of using the RGB channel, we only use the red channel. So you can store different information on different channels in a texture. So, and this is our end result.
Pretty solid metal.
In the middle, we want to do something like carbon, but a simple setup. Before we do, I want to show you something on the mesh. Here you can check the vertex color of your mesh. We painted some gray values onto the mesh, which we can now use in the material. Let's open up the last material. And again, we start with importing 2 textures. And again, one is a normal and one is this time one we use for the base color. Let's take a look on the normal for a second, which opens a new editor. Unreal identifies this as normal automatically and sets up the values it's needing. So we have nothing to do here, which is nice. Let's go back to the material and now drag both of those in. First, we add the normal. Again, not the tiling we want.
That's too big, I guess.
So with the texture coordinate node and some very high numbers this time, we will get much closer to what we are looking for. Now let's use the grayscale texture for the base color. When we directly plug this in, we can see that we have the same tiling issue as for the normal map. So let's just connect our texture coordinate as well with the UVs for these grayscale texture. Nice. When we now hit apply and go to our create, we can see that this fits very well. Now let's use this vertex.
Why is the
color
plastic part pink though? That looks so weird.
And search for vertex color to get that input node. When we multiply this now with our texture output and connect that to the base color, we will now hit apply and go to the create and see our result. So here's our final create with the 3 materials we made very quickly. Let's bring in a floor by doing a right click on this sphere, go to replace actor and select the cube. Up here we go to the scaling tool and then we scale it down on that. We scale it up on X and Y. Now we have a floor we can use.
He's in touch with his feminine side, I suppose. Why does pink have to be feminine?
We can move it around and rotate it to see it in.
Let's check on our program. Okay, it's in the 1600s. So we're almost at like 30-ish%. So we're making progress, I guess, slowly.
In our light setup, and we can move the camera a little bit around. We can also change.
Yeah, of course you're getting called out.
How our material reacts to the different light scenarios. And here we are with our first scene done. So now let's talk.
Luckily, it's just you and me talking, so it doesn't matter.
When we press play, it seems nothing is really happening. With a crate selected, we can scroll down in the details and select simulate physics. When we now hit play, this crate falls to the ground. The disadvantage is that this is only turned on this specific actor in the scene. If we bring in another crate that looks for the player exactly the same, it will behave differently. Because for this second crate, it's not set to simulate the physics by default. This is where blueprints can come in. Let's create a new folder and call that game elements. When opening up the folder, we can do a right click to create assets. We will find a lot of different things, but we will concentrate on blueprints for now. And blueprints can be a lot of different classes, but we start with an actor. And we call that BP_create.
Yeah, it's weird with Lyra, their naming conventions for blueprints is just B underscore instead of BP, so that's kind of weird.
And the upper left, we have
I was kind of surprised by that.
Below we have graphs, functions, and variables. Up here you find the event graph for the game logic, but we ignore that for now. Let's add a static mesh component, which we call create mesh. We still don't see something because we have to set our static mesh crate in the details panel of our added component. So here we have it. The details of this component are identical to the one we saw in our level, including the simulate physics checkbox. We can also tweak it a bit by setting the mass and increasing a bit the linear and angular damping to introduce some track to this actor. So we save this now and go back to our level. When we now bring in our blueprint we just made, also rotate it a bit and press play, you can maybe see it behaves a bit differently.
Nice.
The advantage is when we bring in another blueprint crate, it has the same default values we just introduced. And when we change it in the blueprint, all actors in the scene will change too. Now let's replace our floor with a landscape. We can
landscape
our floor and select the landscape mode. This lets me create a landscape. We do not bother with
so basically we're seeing the same stuff again.
Hit create. Now we have a landscape that we can sculpt, paint, or use landmass tools, but I don't want to cover that. We can change the brush size. For example, the strength and the brush size and the fall off for smoother or sharper edges. I'm not a very good level designer, so let's try.
I'm not a good level designer either.
Something that looks like a small valley. Like that. I'm changing a little bit the brush size and then just really fastly drawing something here. When you hold shift, we can also lower an area, like for example here. And then we can use this tool to smooth out some of the roughness we brought in. But yeah, let's keep it like that for a second and head over making a material for our new landscape.
Maybe in the meantime, we can play some games. Maybe we could play Little Nightmares. Like, I don't want my computer to be like shitting its pants all the time. I gotta see where I'm at. Task manager. Because yeah, it's using 100% of my CPU almost. So yeah, playing a game as well, not gonna work. So we kind of have to like let it run its course. Because we're almost at 2,000, which is nice. Well, like 40%.
Back in select mode, we can select our newly made landscape. And in the details, we will find the landscape material. So let's make a new material for that. We create a folder named landscape and create a material here, which we name im_landscape. First, we don't want to have any glossiness on our landscape, so we can search for fully rough in the material settings, and it does exactly what it says. So now we have a rough thing. So next we want to add the landscape layer blend node. We can add 2 layers.
Layer
One
blend.
we will call sand, and the other we will call grass. And when we plug this in now,
So landscape, nanite rocks, vegetation gameplay framework might be interesting.
And do a left click, we can create a vector node where we can set the color into like a darkish yellow tone. We do it again, but this time with a dark green. And now we hook this up with the 2 layers.
Kind of curious what we would do.
And add it to the landscape.
Like, I don't care too much about
this-
landscape right now. We've seen a bunch of
we do
landscape.
that by going back into the landscape mode, and in the paint tab we can find our 2 layers we just made. But the information needs to be stored somewhere, so we need to create a weight blended info layer, and we do that for the sand in our landscape folder and the same for our grass. So with this done, we can select those layers and begin to paint here. Again, a reminder that this part isn't really my strength, but I will try my best to paint in some grass. You can use the same brush settings as for the sculpting. I think this is enough and that works for us now.
Perfect landscape drawing.
I can hide my simple drawings with some improvements on the material. So let's import some more textures. Here I have 2 tileable textures, one for sand and one grayscale one for grass. So we can remove the sand color node for now, but I will keep the green. We can connect the sand and bring in this grass. And when we hit apply and check out the level, we can see that we have sand here and this very beautiful grass. But the tiling isn't very nice. So let's get back to the material and fix that. This time we will use an absolute word position node, which gives us x, y, and z on a given location. As we do not need z, we will use a component mask to get only 2 coordinates and not 3.
So just the
Our
x and y?
G is y in this case. Now we can divide that by a number to control the tiling. For example, 256 could work. And now we plug that into the UVs. And now when I move around, you can see this is word aligned. Even in the editor, I really actually like that a lot.
That's pretty wild.
So let's copy this part and do the same for the grass. I'm copying it because maybe we want different values for now. So here, let's try like 512.
I mean, does that have to be a power of 2?
So when we hit apply and go back to our level, then we can see the results. So let's get rid of this, go to manage for now, so we don't have the brush. And here we are. So here's our textures, and the tiling is not too bad, but the grass is not what we want. So let's go back here and switch that back to 256 for now. And now some cleanup. So there's a very nice new node in Unreal Engine 5, which is called named reroute node. So we call that sand, and now we can unplug that.
You can reroute now in the material editor? That's pretty sick.
As input.
That's
So
nice.
that's pretty neat. We can do the same for the grass, but before we do that, let's bring some color to the
Okay, so
color.
power of 2
So
is a bit good
we can
choice.
hold
Uh-huh.
L and do a left click. That brings us an alpha lerp, and we can use a grayscale and this green here. Let's make a copy of that and do a second green, which we in this case make a little bit brighter. And with this plugged in now into our alpha lerp, we can lerp between those two values with the grayscale. So, and when previewing this is what it looks like. So now again, we do the named reroute node, name that grass, and also color that green, so it's a little bit better for our overview. And now we can plug this into the layer. So this is a really nice way to keep your graph clean. And very often it's the small things that can make a big difference. You could also make a material function here, but we keep it like this for now. So, and here's the result on our lens.
Some solid grass.
So when we get closer, this is pretty nice and actually what we wanted. So next, let's try to populate this with some grass and some rocks. First, let's spawn some real grass. Before we start, let's change the light direction a little bit to get a nicer spot here in the middle. And then let's create a new folder we name environment. Here we want to import a static mesh from an FBX and another grayscale texture. We keep working with the defaults for now. When we open up the grass clump mesh, we can see how it looks like. So let's
Very
make
nice.
this grass material very quickly. We remove the color and drag in our texture. Where the texture is black, we want to have it mask out the material. So for that, we need to change the blend mode from opaque to mask. Now we can plug in the texture to the opacity mask. When we check out the grass mesh now, it begins to look like we want. Let's bring some color back.
Okay.
We go back to our landscape and we steal the setup by copy pasting this in our grass material. And then we connect that with alpha and the base color, and if we take a look, this looks nice. So how do we get this grass into our level? We could use the
foliage painter
to paint it in,
but
there's an easier way, and we can leverage our landscape material for that. When we look for output grass node, we can add
that's
that.
interesting.
When we select that, we can see there's a grass type we can attach here. So we need that asset. Let's create that asset we find under foliage, landscape grass type.
Yeah, procedural based on stuff. Okay.
Landscape grass.
I mean, it's always nice to do.
After opening it, we can add different grass types, but one is enough for us. So here we add our grass clump, and then we
I think I did, yeah.
density and
I remember
change
now.
the min and max scale a little bit.
Well, I don't think I think it was by default from the marketplace assets.
So next is a
But yeah,
question
they
where
use
spawn
that.
blocks. Here's where the layer blend comes in. We know already where grass was painted. By adding the sample landscape node and changing it to the layer name grass, we are actually done.
This is gonna be wild.
Back in our level, we have now grass. Isn't that cool?
Yes.
So next, let's get
Very cool.
crazy with some rocks. We want to import an FBX named flat rock. This rock has over 6 million triangles. So now we want to change our import settings.
Let's see where we are.
to Nanite.
Okay,
And
so we're over 2,000 now. Almost halfway.
I will speed up this video, but I can tell you that importing and creating the data took under 3 minutes.
So it's always fun having to compile the editor and the engine.
With this done, we can drag our rock into the level. Switching to Nanite visualization triangles, you can see Nanite in action rendering only the amount of triangles needed. If you want to learn more about this awesome technology, check out our other videos, including the one from Matt and Galen, where they show you how to convert your existing scenes using Nanite.
So 6
In
million
this material,
triangles.
we do not want to work with the mesh UVs. So first, let's import another texture for the rock, which is a tileable texture again, and plug this into the base color. And then let's see how that looks like on the rock. So not what we were looking for. So here we do the same as we did for the material, for the landscape, and use absolutely world position, mask that out, and divide this, in this case by a very, very high number, and then plug that into the UVs.
I think I do like 1024 or something.
I think we do something
Yeah.
like 1024 here, and let's see how that looks like. So much better, but when you look,
Still looks
from
kind of
the side,
gross.
that doesn't
Yeah.
look really nice. It's really stretched. So instead of masking RMB, we using Y and Z, so to say. So when we apply now and go back, then we can see it's okay from the side, but now our top doesn't look nice. We can use a little trick here. So we are looking for the vertex normal, and here we can check again with a mask, and this time we only use B, which is Z, which is looking upwards. And then with a lerp again, we can lerp between two different textures. One is our rock, so that's from the side, and then we have to bring something else. Something else in our case can be the sand texture we already used. So we plug this in, and that will have the same issue like we had with the other texture. So we go to our landscape and we steal briefly our setup here. So we could make this now a material function when we use this in different materials, but for our little purpose, this is enough to just copy paste. And here it is, our little nanite rock.
That looks okay.
Let's go back to the valley, and here it is. And we want to add many of them. So for that, we will use the foliage tool. Here we can add foliage assets, but we don't have one yet. So let's create one under foliage, static mesh foliage, and we will name this f_flat rock. After opening it, we can add our static mesh, and let's change some values, like for example the Z offset. We also don't want this rock aligned to the surface normal, and this rock is big, so it should have collision. So we set that to block all, and it also
foliage.
So after saving that, we can go back in the foliage tool and add it to our palette. Here we can change the density and the min and max scale. We could also override other values or do non-uniform scales, but let's keep it simple for now. Let's test how that will look like.
Let's see.
First, we try to get a better overview of the scene, and then we select the rock to be spawned, and now we can actually begin to draw them into the scene, but that's not enough. More rocks. So let's increase
more rocks.
No, that's still not enough. So increase again, and then let's begin to paint. Yeah, that looks nice. So let's begin to cover the whole valley with rocks. So that looks nice. More rocks. Let's add just a few more rocks. So we have now a lot of nanite rocks.
Yeah, we need a little bit more rocks.
Triangle count in this scene, and I think that's good. When we now change the view mode to nanite visualization, you can see a high density of triangles, but there is no noticeable impact on my performance. So yeah, that's where we are. Let's get rid of the rock.
Okay, so they're going to do vegetation next, then the gameplay framework.
Great, by opening up the static mesh. Because there we can check nanite and hit apply. This doesn't have much polygons, but as nanite is a general optimization, we can profit from it. Matt goes deeper in his video about conversion from UE4 to UE5, as does Chris Murphy in his guided tour. Let's add a bit more vegetation. I'm using the assets from the nice sample project Statobot, but this time we want to migrate the trees and the fern from this project to ours. We do so by selecting the assets we want, do a right click, go to asset action, and then migrate. We will be presented with a list of all asset references that we want all. Now we need to choose the content folder to our target project and migrate. Here we are back, and we have now a new folder with a hierarchy from our source project.
We got bushes and trees.
Static mesh foliage we can now add in our foliage tool. For example, the fern. We want a slightly smaller scale in this level, but we keep the density. And now we can select them and easily paint them onto our landscape. Maybe some more here, just to give it a little bit more color. And we can do the same with the trees. Here as well, we want a little bit smaller trees. And as with a fern, we can just paint a bit in here, and until we have some nice trees in our little valley. So now with the fern and the trees, this begins to look like a very lovely scene. But now let's...
Those are very interesting looking trees, honestly.
with the gameplay.
Thank you. Gameplay. Here we go.
Start.
Okay.
Let's press play and see what happens. So besides our crates falling to the ground, we can find some yellow colored actors in our outliner. Many of them are default actors that get automatically spawned, like for example the game mode or the pawn or the player controller. So those three we want to replace with our own. In the project settings, under game modes, we find the default game mode base, which defines what classes are spawned. Also, the startup maps are defined here, so let's briefly change that to our value. And now we want to make an own game mode, an own pawn, and an own player controller. So let's create a new folder and name that one framework. In there, we want to create a new blueprint class. We worked only with an actor before, but blueprints can be made out of many different classes. When we open up an actor in our classes, you will find that our crate is a child of an actor.
Just check up on our code compilation. All right, we're almost at 2,500. So almost at the 50% mark. Ugh. I hate how long this takes. I wish I had like a supercomputer. I wonder like how fast that can go. Be like, I just need a better CPU, I think. Maybe that could be like my next purchases and everything. Because like, you know, I gotta finish my yard. And then once the yard's finished, maybe I can save up for a brand new CPU, maybe a motherboard as well. Let me just check up on my finances real quick while we're doing everything. Okay, we're doing good. All right, let's jump back into the video.
And a character is a child of a pawn, which means they inherit functionality from their parent. But we will based on the game mode base and name this one BP game mode for now. Next, we need a character. A character is based on a pawn and comes with built-in functionality we will use. We will name this one BP bot.
Bot.
So imagine this being the.
Have you managed to pay up your college debt? Hell no.
But we also need to
not even close. Like I still pay like you know
we will need a player controller.
They delayed payback stuff because of COVID and everything.
Later. We name this
but you know I've been paying, you know, every couple of months I've been throwing like a couple $100 into it, you know, and right now it's, I believe it's 0% interest, so I'm able to like take out huge chunks of it, but I'm nowhere close to it.
We could even have logic here the game should take care of.
I can take a look real quick.
We will only override some default classes here. First, let's add our player controller here. So instead of the default one, we want to use our BP player controller.
The provider always is changing.
Default pawn class, and our BP bot is a character that's based on a pawn, so we can add that here.
I'll tell you how much I owe in this one set of stuff.
To use our own game mode, we could add it to the specifics of this level in the world settings. If we would have different game modes for different maps, but here we just want to add it as a default for all maps, so we do it in the project settings. And here you can see
like it's not too bad, but there's only one set of loans. So the total for these two loans together is about $24,000.
Game mode will use it automatically when it's in the scene. This blue arrow shows us the direction the character.
So one of them's about 8,000, and the other one's about 16,000.
Will be placed on the ground.
So usually I throw about 500 or 600 bucks
when we now hit play,
across the two loans a month.
This button we can detach from the player controller to get back to the editor controls while the game is even.
And you know, sometimes if I get like some sort of bonus at work, I'll throw a little bit more.
And other blueprints we made. So now we have.
Well, it's just how the loans are split up. Like, you know, there's different types of loans the government can give you. I don't know. Student loans is stupid. It's predatory loaning, and it's dumb. I mean, and this is only two of the loans. The other one is with a bank, and you know, my mom's helping me with that one. Like, it's not too. I don't think it's too much. I actually don't really know, but my mom takes out money from my account, you know, and just pays it through my money in account. Like, she has access to my Bank of America account.
Character around and has a lot of values we can tweak. Let's make the capsule not hiding in game so we can see it when playing. When we now press play and detach, we can see the capsule. Visibility is not great in the video, but it will serve the purpose for now. Let's stop and go back to our character blueprint. For our little game, we don't want to look through his
So yeah, it kind of
eyes.
sucks. I
We want
don't
a
think
camera that's looking from top down. To do that, we will add
Like,
a component called
I don't think it was worth it at
with
all.
some neat options.
Like the student,
Wouldn't
the
take,
actual
of course,
college.
the arm length, but before we do, let's attach a camera.
Like,
to the
you know,
player.
I got to where I am in life. Like the school didn't do too much. That's why I'm always like hesitant for people to like, you know, they want to go to like a game school. I'll be like, yo, don't do that. There's so many like free avenues or cheaper avenues to get to the same place. So I'm always like, yo, don't. If you can help it, don't go to school for video game development. Like go to school for like coding and programming and stuff.
Has some more handy features. It could check for collision to adjust the camera. We don't want that here. So
But actual game development, you know, I think it's a waste of money.
How this looks in game. Awesome. This is actually what we are looking for. So next, let's do some movement. Again, there are several ways to do that. In our case, we want to implement the input the player is giving to the player controller we made. Remember the controller?
Oh yeah, well, I was a teacher, and when students asked me if they need college, I was like, nah, not really. Yeah,
This is our first
pretty much.
logic.
Yeah, like you can buy courses online.
Here's a begin play.
You can learn online,
There's actually more. For example,
and you know, you can make, you know, making games nowadays is super
in his lifetime. Begin play with
available, and you know, I wouldn't want to say easy, but easily accessible.
Now we
The tools are free,
display some
like
text
Unreal Engine and Unity, and you have other things like Game Maker and
to begin play.
all these other things.
So when we press play, you will see
So,
in the upper left corner printed.
You could definitely save yourself a lot of money by just like
Here it is.
not
So
worrying
let's go
about it.
back, stop it here, and then hook this up to tick. So when we now hit play, you will see it's printed rapidly every tick. For that reason, you want to be thoughtful what you do here. Complex things on tick will have an impact. But we want to move our character every
Yeah,
tick.
discipline is one thing. You know, having to owe thousands of dollars to the government because you went to school is pretty good motivation to try to get a job and learn, I
So this
suppose.
pin is now our pawn we can give orders to, and we will find add movement input on the character. Now we hook this up to the event, so it's get called every tick. For simplification, let's say this goes to the movement component in our bot. It needs a direction, so let's set the X of
So every tick he's adding movement input. So he's just gonna be
witness our actor moving in
Yeah.
one X direction until it gets blocked.
yeah,
Now we
okay.
need to figure out in which direction we want to go. In Blueprints we have access to many things, and this includes the location in the world under the cursor. You can go deeper and have different trace channels, but we keep it for everything that's visible for now. Here is the hit result, and as it has many information, we can break this struct to see what it gives us. In our case, we only care for the location. As we now have our location in the world where the cursor is, we need one more, and that's where our bot is in the world. We can do get actor location on the pawn. With this both locations, we can use a vector mask function called get direction. It gives us a direction of a vector from two locations. This is exactly what we need here, so the character moves in the direction where the cursor is. When we now start the game, we will see the bot will be with the camera attached following the cursor. So he's going left and right and down.
That's pretty cool.
Super cool. I didn't click in the viewport when the game was running. If I would have, you would have seen the cursor disappear. Fortunately, the player controller managed that, and we can go to the details and check show mouse cursor. So if I now start the game and click into the viewport, the mouse keeps being rendered and the character following that.
Input
As
time.
we do not want to follow the cursor all the time, we need to introduce some player input. To add input, go to
So is it like a point and click kind of thing? I guess that's what it's
scroll
maybe
down
going
to
for.
Input, where we find different bindings we can make. There are axis bindings and there are action bindings. We will only work with action bindings, and you can imagine this like digital on and off switches. Let's add a binding, call that toggle movement. We can click this little icon here to press a key to bind that to our action. Here I do a left mouse click, so you can see this is mapped now. Back in our player controller, we can remove the begin play for now. And now we can look for the new event we introduced with the binding. We will find toggle input here and add it to our graph. So this has two execution pins. One is fired when it's pressed and when it's released. So now we only want to follow the cursor while we hold the mouse button down. So to do that, we will add a variable here and call that add movement. This is a boolean, but there are many more variable types. in toggle input, we want to set this variable. So when it's pressed, is fired, we set this to be true. And then when we copy paste that, attach this, when it's released, we want to set this to false. And now we only want to add movement while this is true. So we get the variable, and from here we can look for an if or a branch node. With this, we can say execute this order only when the variable is true. So we are
Okay, so it is a point and click kind of thing, huh? Or like
he is standing around, and when we press the mouse, he's moving in that direction,
Mhm.
and he stops when we release it.
all right, let's take a look. All right, we're almost in the 3000s. We're at 2785, so definitely almost halfway. Once we get to what, like 2900, it will be halfway. So yeah, slow as fucking process, but you only have to do it once when you build the project initially. So let's keep watching. Maybe by the end of this YouTube video, in the next like 45 minutes,
So
we'll have better progress with the compilation.
The feeling of really controlling our little capsule here. But just moving a capsule around is kind of boring, so let's get an animated character. Back in the character, we had the skeleton
Yeah, I was just watching that video you sent me, Sancho. Pretty
To do
cool.
that, let's create a new folder and call this character.
Alright, I gotta stop watching videos. I gotta pay attention.
In the import menu, you can see Unreal already identified it being a skeletal mesh and ask for a skeletal.
Okay, so we're importing a character, I guess.
First skeletal mesh
Yeah.
we bring in, so we want to have import mesh checked.
Animation, AI controllers,
Now is automatically generated
interaction
images.
components, effects, camera shakes.
Rest, we
Okay.
leave it like it is, and then we hit import. When we open up our character folder now, we can see different assets that got created. We already know about the materials, but we have a skeletal mesh and a skeleton. Let's open this. The skeleton that got created from the mesh has all the hierarchy of its bones. Let's show the bones for a second. Most animation assets will need to reference one skeleton. So the second asset we have here is the skeletal mesh. You can see this as a skin, so you could have different meshes using the same skeleton. It contains data like the material slots, LOD settings, post-process animation blueprints, and more. As we don't want this robot to be gray but more colorful, let's make his materials quickly. It will not be massively different
Will it be
from what we
yellow?
have done before, but he comes with some more textures and some extra nice things for his face. First, we import all textures. It comes with a grayscale albedo, an atlas for facial expression, masks, and a normal map. We start with the albedo, and we just plug this into the base color, and then when we take a look at him, it's still gray, but a little bit more interesting. So now let's add color. We use a blend overlay node, and then attach this to the base color, and use the parameter here. And now let's...
And right now I'm just kind of looking at Reddit and listening to this thing.
So when we look back in our characters, this is what we got. Now let's take a look at a texture. So this one here. So in the texture editor, we can display the different informations in red, green, and blue channels. Here we save metalness in red, in green have roughness, and blue has the ambient occlusion. So back in the material, we can bring in this and connect metallic, roughness, and AO to the different pins.
Yeah, the whole material setup and everything like that, and like technical art, yeah, a whole foreign concept to me, really. Like I know how to kind of use it, but there's so much you can do.
But they have the wrong color, so let's fix this. We can use the mask texture and again a lerp node. The green channel separates the orange parts from the metal parts. So one part is orange, and for the other we add another 3-vector node and change the color to a gray. When we hit apply and go back to our character, this is how it looks like. So some last touches.
Yeah, that looks cool.
Normal and give him some emissive parts. First we bring in our normal map and connect that. And then we have this mask texture, and that uses the red channel for emissive parts of the mesh. So we can multiply this and plug it into the emissive output. And we multiply this with a color. For the color, we take a very, very light blue. And if we hit apply and go back to our bot, we see his main body is ready. So the only thing left is now his face.
Yeah, I was thinking why the face is not
So
glowing.
for the face, we have one extra background texture.
Oh, it's
So
its
let's
own
bring that
material,
on.
okay.
This time we will plug this into the emissive color. And then we will hit apply and see how that looks like on our bot.
I hope they're gonna have like
So
animation on the face to make it like smile and be sad and stuff.
Which is mainly a texture with an alpha masking a
Yes.
expression, and it's
Okay, cool.
So to select the face we want, first we want to add this texture to our background texture. So we use an add, and we can use the alpha channel for that because that's where the information is stored. So now we can see the whole texture added to the other. But we want to control the color, so let's multiply this with the color. And then again, let's change it to a bright light blue. And add and plug this into the add. Now we will use a flipbook to help us select what kind of face we want from that.
So they're gonna have
And we will use
blinking
the
and dead and
so
happy
already
and
with this
normal.
defaults, and with this
Okay.
mode, we can see some animation and it's shown on a 2x2 face. So let's fix that. We will bring in the scalar parameter and change this to 4 because this is the amount of rows and columns we have. So we can just plug this in here and here. And now it is running through this like an animation. So if you want to animate a texture, this is a nice way.
That's
But
cool.
we want to set it to a fixed value. So let's bring another parameter, and when we're changing that, we can change the face. But in our case, we will keep the standard one, very simple like this. So hit apply, and then we are done, and we have our character with a face, which we could animate if we want.
He's low-key
Add him
adorable.
to our bot and do some movement adjustments. Here in the bot, on the scheduled mesh, we can add him now. So here it is, but it's a bit in a wrong location on rotation. Let's fix that. First, we rotate him 90 degrees, so he's facing in the forward direction of our character logic. Next, let's take a look at the capsule. That's a little bit too big for him. First, we change the radius to be a little bit smaller, and we can properly reduce the height a bit. So back in the mesh, we can change its relative Z location so it fits into the capsule. So now we have a capsule that represents him a little bit better. It all depends on your needs, but for our little games, this is okay. So when we hit play, we have the character and it's moving around. Nice. But we can see some issues. Most obviously, he's not facing in the direction he's moving towards. So back in the bot.
I mean, what's the
we
point of
can
this bot
see
having a face if you can't even see the face from your
insert
camera?
rotation, where we can find orient, rotation to movement. We can also increase the speed, how fast he's doing that. So with this done, we'll face in the direction he's moving to. But
Oh, that is so disorienting.
we can easily change that by going back to the spring arm. And there, for the rotation, we can switch from being it's set to relative, what it's attached to being set to vert aligned. So when we now hit play, it is looking like we want. And this is beginning to feel like a real game. So he's following the cursor and the camera stays fixed and he follows it. Animations are missing, but before we do that, let's go back to the character movement and make some changes. For example, how fast the bot can accelerate. The next thing is we also want to increase the maximal step height and a little bit the angle he can walk on. We want to set his maximum speed to 400, and for now we will decrease the ground friction and also reduce how fast he is stopped when no input is given. And we will do all that so he is slower accelerating and not immediately stopping when no input is there. This may feel a little bit like he's on slippery underground, and we could increase the ground friction a bit, but we will keep this until we have some animations in. First,
Let's see where we are. Okay, we're in the 3000s. See, yeah, a lot happened. So we're almost in the so we're at 3600. So we jumped a lot pretty quickly. So that's nice.
we will create a new folder naming it animations. Here we will import animations from 3 different FBX files. In the import menu, first we will select our skeleton we already have in the project. We will also not import the mesh as we also have that. So now it's only the 3 animations we are getting, and that gives us 3 animation sequences. Let's open the idle, which opens up this editor. So here on the left are some asset details like play rate, and down here are an asset browser with animations for the skeleton. We have a walk and a run and the idle. Now we need to connect this to our game logic, and we do this by using an animation blueprint for that. The animation blueprint is also based on a
I mean, is he just gonna make he's just gonna make a simple blend space, I guess?
Bot. And when we open this up, you can see here's a preview. Below there's graph, functions, and variables from normal blueprint. But the main thing here is the animation graph where we play and blend our animations. And there's the event graph for the logic we will use in a second. Let's start extremely simple and just drag in our idle and connect the pose with the output pin. After hitting compile, we can see the result in this preview. Now let's add this to our BP bot.
I don't like how it flickers sometimes.
We can go to the skeletal mesh component. Let's go to the viewport to see what we are doing. And here we change the class to our animation blueprint. So he's playing the idle. Back in the game, he's playing the idle pose while sliding around. Instead, just playing one animation, the animation depends on the state he's in. So he's either standing still or he's moving. We will use a state machine.
So he's gonna make a state machine for that, but I feel like you could just do a blend space for that.
Locomotion. So it spits out a pose, and that's something we connect to our output pose here. Let's go inside of the state machine. It has an entry point where it starts, and we can add a state and call this idle. And we can have another state from that idle and call that walk, run. So this is
my hand is still cramping so bad.
we start at the beginning idle, and we can switch to the walk. And the arrow in the middle is a transition. So we also want to go back from walk to idle. So let's go inside of the idle state. Here we drop in our idle animation and connect that. So it plays the animation when he is in idle state. And when we go back, we can also go into the run and walk. And here for now, just takes a walk. We can extend this later. So now when he's in that state, this is the animation he's playing. So next we need to decide when do we go from idle to walk, and that's where the transition rules comes in. Here we can say you can enter or can't enter the state, but for doing that we need some data which we will get from the event graph. Here's an update node, it's like the tick in blueprint, and here's also a try get pawn owner node that will give us that pawn. But let's first make a check if this currently has a pawn, so we try a isValid function here. And with this now we can drag out of the pawn and search for get velocity, which will give us the bot's velocity vector at that given moment. With
get the length,
vector mass, vector length x and y, we can get a float that represents.
We're so smart.
He's not jumping, so we don't care for the z direction. And this value we save in a variable we call ground speed. So when we connect this now, this gets updated, and we can test this by using our beloved sprint string node. We can plug in the float, and a conversion node gets automatically added. So when we now play the game, we can see on the left side its current speed, and it's up to the maximum of 400 we set before. So back in the animation blueprint, we can delete this now. And in the transition rule, we can use this now by getting our variable in and check if this is bigger than 0. So after doing that and pressing play again, we can see he is actually going into a walk state, but if we stop walking, he's not going back to his idle.
He's kind of sliding around still. But I mean, I'm sure he's going to fix that.
Going from idle to walk, but the transition back is always set to false. Let's fix that by getting in the ground speed again and check if this is smaller or equal a number. And we can use like something around 5 here. So now back in the game, you can see that when he begins to walk, his animation is played, and when he begins to stop, then he's going back in his idle state. We can extend this now. Let's go into the walk and run state, because at a speed of 400 the walk will not work very well. To improve that, we can use a blend space. It can be found under animations and then blend space 1D, and we base this on our skeleton. We name it BS walk run.
All right, now he's doing a blend space. Okay.
And when we open this up, you can
Cool.
see axis here below the character, and in the details up here we can name this axis to speed. And we can also set the maximum
I
to
am
100
speed.
to match our character speed we set before. And now we can drop some animations in, like the walk and the run. Depending on the input speed, it will blend between these two. But how do we know that the blending is not feed sliding? Unreal Engine 5 comes with a very cool analyst feature for that. We can choose locomotion as an axis function, and the analysis
That's
is
interesting.
below the foot bones. So we can look for the bones, which would be foot left. So we put foot left and then foot right.
What does this do?
And once we have done that, he knows where the planting is happening. So when we press analyze, he will match the animations to the right point on the axis. It might have been a little bit subtle because my initial points weren't too bad. But with this blend space now, we can
That's
drag this
interesting.
in and use our ground speed to drive.
I wonder if we can do that in our
axis.
project. I'll have to remember
So
that.
if we now hit play, you can see the character following the mouse and blending from an idle to a walk to a run. So in a very short time, we have our character running around in the world and reacting to our input, which is pretty cool. So as the bot is ready, we can...
Where are we? Oops. All right, so we're at 4,850. So yeah, it's starting to make some plays here. Things are happening quicker. So we're almost done.
do even more with it. Let's drag the bot into the scene and control him with an AI controller. Because of our setup, having the player controller controlling the bot, we can also have an AI controller as a brain for the body. So back in the blueprint window, we can search for AI and select the AI controller and name it BP_AI controller. When we open this up and go to the event graph, we will not add movement or use a tick, so let's delete that. There is an AI move to function in the AI controller we can use to give him some orders. So now, how and why and when do we give that order? So let's do something simple first and execute this function a few seconds after the game starts. We use a set timer by event function and we set this to like 3 seconds. Now we drag this delegate out and type custom event. And this event we call simply move. So now we connect the AI move to function, and the last thing we need is give this order to the pawn which we currently controlling. So back in our map we select him, and in his details we find the AI controller class, which we set to our newly made BP AI controller. The last thing he needs is to move around is navigation data, where blocking is, etc. So we go to the create menu, type navmesh and select the navmesh bounce volume. When you press P, you can make the navmesh data visible and invisible. Let's now cover the whole area. We want our little robot to be able to walk in, and then scale this up a bit. This should work for now. So when we press play, we can walk around and you can see him begin to run after around 3 seconds, but he's trying to reach 0, 0, 0, because that's what the destination says by default, and we will keep it like that and come to this later. All bots have the same color, and to avoid an identity crisis on our bots, let's change that. We will use the construction script of our bot for that. When we select our mesh, we will remember that our bot has 2 materials, and his body material is element 0. This material has a parameter I already renamed to color. Back in the construction script, we can grab the mesh and drag it into our graph. And from there, we add a node called create dynamic material instance. And we do this on the element 0, which is our body material. So here we can use the instance and now set a vector parameter with our color. So the parameter name we change to color and change the color to a blue. After hit compile, we can see him in blue in our scene. But now all bots in the scene would be blue. To change it per bot, we can drag the color out of here and promote it to a variable. And we name that color. And with this little eye icon here, we can expose this variable to be editable per instance. You can see this also up here. And then we change it back to our orange we had before. Now we can give this little bot his own individual color by going here in his details panel and picking something like, I don't know, something like a blue. I will settle on that for now. So we have our own controller and an AI. So let's do some more.
Okay, where are we at now? Still 4,893. I thought we were going to see, you know, continued jumps in how much we've been compiling, but I was wrong. But we are less than 1,000 away. So that's good. So let's continue watching. Did anything change in the meantime? We're at 4,900.
Game logic. First, let's bring in some more props. So we go to our props folder, import, and then we import a wall, a door, an orb, and some meshes for a pressure plate. When we import them, they conveniently use the same materials we already created. So that's nice. We will first start with our orb here. In game elements, we will create a new blueprint based on a simple actor and call that BP orb. When we open this up, we can use the content drawer to drag and drop our meshes into the scene, which is automatically creating static mesh components. We can make this a root element, and then on the details panel we can go to the collision and set this to overlap with pawns only. We will use this later. But first let's see how we can spawn that into the world. So we go back to our player controller and we want to trigger an action depending on an input. So once again,
We're just doing inputs. Okay.
And there to input, and we add another action mapping. We name this one spawn orb. And we press here and hit spacebar to bind that to that action. Back in the controller, we search for spawn orb input event, and then on the release, we use a function called spawn actor from class. And the class we want to pick is a BP orb. So with a right click and split, we can access the variables of the struct. So we need a location to spawn it. We can use the same location where the bot is in the moment we hit the spacebar. So we add this to the location, hit save, and now we can walk around and spawn orbs. With orbs in the
Fuck yeah, spawning orbs.
To collect them. So instead of walking to 0, 0, 0, we want the bot to go to an orb. And we can use a function to find an orb, and we call this function find orb. This function should output if it found an orb, so we do a boolean which we call success, and we add a second one and change the type to an actor, which we will name orb actor. So let's make the logic for that. First, we want to get all actors of class. And here we want to look for all.
Today is a nice day.
Orbs.
But we're working in game dev, so
basically a list.
we're doing bullshit.
Get lengths of that list to check if something is in it. So if this area is bigger than 0, we can use a branch, and if this is true, we found something. And if it's false, we say we were not successful. And if it's true, we found orbs. So now we make this simple and just get the first orb in that list.
I mean, do you really want to use get all actors of class? Like they always tell you not to use that.
And go back to
Or at least not on
our
tick.
graph, we can track in our function. So we made our own node we could now hook up like we did before, but in this case we can make this function appear, and when we drag this in now, it doesn't have execution pins. Be aware that also means each time a value is needed from this node, it will be executed, but that's okay for here. So if we are successful, we will do the AI move to command, and we will use the orb actor output and plug that into the target actor. And then when the AI reaches the destination successfully, we want to move again. In addition, we want to change our timer and check that this is looping, so it's checking every 3 seconds. When playing now, we can spawn orbs, and our little blue robot will go and run to the orb. But as the orb still will be the first in the list, he will not move to another. For that, we need to remove it from the world. To do that, we can use events the components can give us. For example, the begin overlap event. We already know this actor will only overlap with pawns because that's what we said in the details. That includes our own bot and the AI bot. Here we get the actor that begin to overlap with this orb. We don't want our player to directly remove it after it got spawned, so we have to differentiate between them. So we cast to a pawn. Carefully with casting, it has hard references, and it means when an actor gets loaded in memory, everything it's casted to will also be loaded. Now we drag out the pawn and we can ask if this is player controlled. As we have an AI and a player controller, this will give us a desired result. So if the bot is not player controlled, we will destroy and thus remove it from the world. Here we are. So now let's hit play and see what it does. We can spawn orbs, and the AI now begins to follow us and collecting those orbs. So here we have it, running around, spawning orbs, and having a little AI following us. Now let's add some more interaction and do some more games.
Okay, let's check our code. Still, still within the 4,000s. That's upsetting. We had such a huge leap. Like within like 20 minutes, it did like 1,000 in 20 minutes. So this, I guess, this last like 900 or something. Ones are going to be annoying.
Game elements. We will do a pressure plate that will open a door, and we want our robot to be able to trigger it. First, we create another blueprint actor and name this one BP pressure plate. And when this is done and we open it up, we can drop in our frame and platform mesh and then make the frame our root. What we want to do is move the platform up and down when something stands on it. To do that, we will add a box collision component that will serve us as our trigger. So let's scale this up a bit so it covers the area we want. And now we want to add a begin overlap event like we did before with the orb, but this time we also want the end overlap event. And we now want to test if this is working. So we use our print string again, we keep the hello for the begin overlap, and we add another one for the end overlap where we say goodbye. So with this done, let's go back in our level and get into the content drawer and just look for our elements, bring in the pressure plate. And when we press play and move around, you can see the hello and bye being triggered when we begin and end overlap. So this is already working quite nicely. But we don't want to output some text, but move the platform mesh up and down. So back in our pressure plate, we will first remove this print string node. And to do the animation of the pressure plate, we will use a timeline. And we name this plate animation. So when we double click, we can add different tracks to this one. But first we want to go pretty fast, so we set the length of this timeline to be ½ second. And next we will add a float track. So this track we will use to animate the plate movement. Now we can add some keys. So the first key is at 0 second and the value to be 0. And then we do another key, and that one will be set to 1 after ½ second. And with these buttons, we can focus on that area. So this value will increase over time from 0 to 1, and we will use this to move our plate. So here is our float pin that will give us a value when the timeline is playing. We will take the platform mesh in here and look for set relative location. By start, this is 0, 0, 0. We want to have this updated when the timeline plays. As we only want to change the z value of this vector, we will use one of the mask nodes and search for multiply. The pins here are grayed out because it's wildcard pins that can become different variables. They get automatically changed when I track something in. And now we can split our location vector and connect the output to the z component. So when the platform reaches 1, we want the plate to be at around -20. So let's hook this up in the timeline and we can do it play and reverse when end overlay with plate. So now back in our level we can run around and you can see it's already triggered, but maybe a little bit hefty. So before we continue, let's stop here, go back and fix this. The value is a little bit high, so we go to -10 and I think that should work better. So let's play again and see how that is doing. Yeah, that's what we want. So the plate is moving down and up. So we have the pressure plate. Now let's
It's very subtle, but yeah, that makes sense.
our door and call this one BP door. When we open this up, we do the same as before. We will go to our props folder and first we will bring in the wall frame and make this one the root. Next we need the two door meshes. It's the same mesh for both, so we will add 2 of them. And let's name one door L for left and the other one door right. As we want them to move around here, but it would be easier if the relative location would stay at 0, 0, 0. So let's do a small trick. We will add a scene component and we call this like anchor underscore L. And we move that to the proper position. Then put the door under that anchor. And
okay, hold on. I think we're done. Yeah.
Door. Location to 0.
Oh boy.
We do the same as before.
Okay. So we finally were able to finish compilation. So now the editor is opening. That whole process took, I don't know, like an hour and a half, maybe 2 hours. But now it's opening, and you know it has to compile a bunch of shaders for that first time, so that's gonna take a while. So we'll come back to this once it actually fully opens. But at least the compilation is done.
We do the same for the other side. So we add another scene component and call this one anchor underscore R. And then move this to its proper position on the other side. In this case, the door moves in the opposite direction as the other, so we rotate this one 180 degrees. And now we can put our door under the anchor and we have a setup we can easily work with. Back in our event graph,
Can you move things over X time in Blueprint without a timeline? I feel like there's an option, but I couldn't find it.
The first one we want to do.
Well, you have to have, you know, delta time in some form, so that's usually why they use tick. There is like get delta seconds that you can use, but you have to like, you know, kind of call it over time. So usually timeline is the best way to do it, or, you know, tick or looping timers or something.
Is calling this one open door, and then we need a second one we will call closed door. And again, we will do a timeline calling this door animation. This is nearly the same setup as before. We will do one tiny thing different, which you will see in a second. So door animation, and then this time we will make this also as short 0.5 seconds. We could also do vector tracks here.
God, this initial opening is taking so long.
0 to 1 space and tweak the values.
Like it's on my C drive though, so it should be on the SSD.
Without the need of changing the curve every time. So the curve we want to model just like how in this case the animation is played. But first we need this first 2 keys, and then we can do it a little bit more interesting by selecting those keys and
let's just keep watching.
Linear to break, and that gives us tangents, and this tangents here we can use to manipulate the curve, so we can bring this down to have a more interesting sliding. And back in the graph we can take both door components and again look for set relative transform. We put this under the anchor, so that will help us a lot. Again, we split the vector, and this time we use a multiply again, and we will multiply it with -70. We connect it to the Y component, so the door slides in and out of the frame. So open door should play time forward, and close should play it in reverse. So this is it, and for a quick test, we want to see if this works, so we will get back our begin play. We want to open the door after a few seconds. I normally prefer the set time setup, but we will use a delay node, which will work for now. And then we will open the door. So we can go back to our level, look at our BP door, and drag that into our level. Let's try to find a nice spot, like here at the entry or exit of the valley. So we have to try to open that. We could properly place it a little bit nicer, but I think this works for now. So et voila, after 3 seconds, the door will swing open. So how does the plate now tell the door
At least you shouldn't have a lot of shaders. I mean,
when to open?
I don't know what it's really doing.
Look into blueprint communication.
It's like 5,000 something.
And that is using a known component. We can create a blueprint here, and we find an actor component. Let's create one, and let's call this one BP interaction component. Imagine this to be a small container for game logic you can add to any actor in your project. So when we open this up, it looks like any actor blueprint we have seen before. But
we're kind of looking at this instead of watching the video, sorry.
Let's remove this for a second. We will do something extremely simple here. We create a custom event that we can call from outside later. First, we call start interaction, and then we do a second one, and this one we will call stop interaction. Next, we will use an event dispatcher, which will give us the possibility to shout out into the world that this event occurred, and we call this one on interaction. And up right here, we can add a variable, and we keep it a bool and say simply on. Now we can drag it in and call this one.
Well, I'm excited the whole compilation is done. Now we just gotta wait for shaders.
And then we do a second one on stop
Like the code
interaction.
compilation. Now we gotta wait for shader compilation, which is fun.
That's all our component will need. So let's hook this up. In the pressure plate, we can now add our new component we just made. There it is. So let's move the overlap events a little bit to the side. And then we can drag in our component and use it as any other. From here, we can call the events we created. Start interact, on begin interact, and then start the animation. And also stop interaction when the end overlap is called, and then play the animation in reverse. To show this is already working,
a lot of fun stuff.
go back and use our print.
Yeah, 5K. Yeah, in theory, yeah, 5K should be done in a few minutes, but we'll see.
When the interaction starts, and we do another one, and we just say off when this happens. So with this hooked up, we can test if this is working. So let's start our game and move our character around.
So where are we at? Now it's 4,300.
And off. So this is already working quite nicely. Now the door needs to react on that. Back in our door, we can remove our test code for opening the door. And at begin play, we want to listen to the event dispatcher of the component that's calling out into the world that an interaction started or stopped. First, we will add a new variable type and call that trigger. Then we change the type from a boolean to an actor object reference, because any actor could actually have our interaction component. We can drag this variable in, and then we can check if this is even existing. So we do a right click and change this to validate get.
What we gotta do next, because right now it's gonna open up just like the, it's gonna ask me if I want to make a project. It's gonna ask me like if I want to open a project or anything. So like, once this is finished, and it opens, we can close out of it, and then basically move. I guess for now, like while that's doing that, I'll wait till this is finished. I want to do one thing at a time, just for the sake of the tutorial. Once we actually put that up, so once this is done, we'll kind of continue from there. So yeah, 3,600 roughly to go.
And now from that trigger, we can move this pin out and search for get component by class on that actor. So here we can check if this actor has a BP interaction component. So again, we check if this is valid. And when both is the case, we know we have an actor here that has our game logic we just created. We can track out here and assign a custom event to this event dispatcher we called onInteract. So at begin play, we assign this event to the event dispatcher, and when this is calling out, we can react on that. We can now use a branch again to decide what to do when this is true or false. So if it's true, we want to open the door, and when it's false, we want to close the door. And with this, we are done. So let's save and go back into our level and set the trigger variable by selecting the door. And I forgot something. So we have to go back to the door and make the trigger editable per instance with this eye icon. So let's compile and go back. And when we select the door now, we can use a picker to select the pressure plate. When we now start the game, we can walk onto the plate and that triggers the door. And it leaves the door and open and close. And it also means when we now spawn our orbs and our little bot collecting them, we can make him open the door for us so we can safely leave the valley. Woo! Even after so many years, I still love the moment when all these little features come
You
together.
love it when a plan
By the way,
comes
we also
together.
can push the crate onto the pressure plate because we didn't check who's overlapping with it. Let's do a bonus round and add a bit of polish by adding effects, sounds, and a bit of camera.
Okay, where are we standing now? We're in the 2000s. So, slowly but surely. But don't call me Shirley. So, maybe by the end of this whole video.
Shape. We will start with a dust effect for the bot's running animation, and first let's make a folder and call that effects. Here we create a completely empty Niagara system, and we will call this one FX dust. So let's open the Niagara editor. Again, we have in the middle a big graph. Here are some parameters, and here is a preview. We will do something extremely simple. First, we want the system not to loop, but only play once. Next, we need an emitter. We could use one of the many templates, but we'll start an empty one. This also has life cycles like an actor, but in update, we add a burst, a spawn burst. And let's add something like 10 particles. In particle spawn, we can set some particle values. First, we set the color to do something that could look like sand. Next, we want a bit of randomization for the size of the particle. So let's check uniform, random uniform, and do something between 2 and 4. We also want to randomize.
So some good information about Niagara here.
Gravity we will introduce in a second. And next we want to add some velocity when the particle gets spawned. Adding this also needs a solve forces module, which will be added when we hit fix. Instead of a linear force of all particles, we want to switch to a cone, and the direction of the cone we want to set to -1 to fit our character later. So in preview, you can see now 10 yellow particles moving in -x. We could change the velocity speed, but we'll keep it for now. There are many more things we can do with our particles, but we will keep it simple. As this should be dust, we want to scale it up over time. So in particle update, we will look for something called scale sprite size. This gives us a curve, and we want it to be much bigger, like maybe something like 15 when it's the end of his lifetime. So you can see now they are getting much bigger. Now they should move a little bit more interesting, so we can add a curl noise to get a little bit of chaos. We can increase the strength a bit, which gives us this. So next, we could also change the frequency, but we will keep it for now. Next, let's add some gravity. So if we add gravity,
Okay, now we're under 2000.
They will by default fall down with -980. We do not even want a negative value. So like this, in our case, we want to get it a positive value. So that's much better. Maybe this is a little bit much. So like that. Here is where also the masks come in that we said earlier. Last thing is changing the alpha over time so it blends out. We can use the scale color, and we can change this from a fixed number to a float from curve. Now we can track the 0 value to happen a little bit earlier.
And gas, why would you use wait input release instead of just applying the ability on pressed?
Niagara is very powerful, and I'm using only a super tiny piece here, but we need to move on and see how we can use a dust now. So spawn that on.
Well, you might want to have like
animation and
because like when you have wait input release, it returns like, you know, the time between you activating the ability and when you let it go. And maybe you want to have like, I don't know, a charged ability where like the longer you hold it, it influences the strength of the ability, because you get, again, you get returned that float value. And I think that's more or less why you would want to use wait input release if you wanted to. You would get that data to know how long the person was holding down the ability if you wanted it that way. So I think that's the main reason.
The run animation. Let's change the camera angle and stop here. Below of the camera we have different tracks, and one of them is called notify. We can scrub to where the right foot is touching the ground, where it's planted, like here for example. Right click and add notify is where we find play Niagara particle effect. When we select this, we can
no problem.
add our dust effect in the detail. And when we know moving on the timeline, we can see it gets spawned and played once. But it's spawned at 000 of the character. And
like, just to give a practical example, in Overwatch, you have a character named Baptiste who has a crouch thing where, like, if you're holding down control, you get like a charge, and when you let go, he jumps at a certain height based on how long you held down the ability. Same thing with this guy Doomfist. He has a punch that if you charge, the stronger it will be, the further you travel, stuff like that. So I would imagine that's mostly some use case scenarios that I would imagine in my head. Okay, so we're under 1,000 now. So let's just wait this one out. And we'll see what happens. Patience is a virtue. All right, here we go. Almost there. This last section is going to take forever, I'm sure. Because like after it's done compiling shaders, like is it going to actually start increasing the percentage of actually opening it, or is it going to like finish compiling shaders and then like 2,000 more are going to just magically appear, and then it's like, oh, we're not done yet. Yeah, that's probably what it's going to do. Like, again, this is only going to open the this is going to open up the the dialog box of like, okay, do you want to open a project? Do you want to create a certain kind of project? Yeah, so it's, you know, opening more and more stuff. All right, but it did, now it's at 75. We're almost there. I'm just glad there was no compilation errors, because that could have set us back a long time, you know, having to restart. All right, the famous 83%. Here we go. Okay. And here we go. We have Unreal 5 now, and we can create game projects. You know, we have, you know, all these different types of templates and everything, all well and good. So now we can actually move our code and our content to the same directory. So what I'm going to do, I'm going to close out of Writer. Let us go now. Let's have in one folder, we have Unreal. Yeah, True Nut. We're almost there. So now what we can do, we'll have the 427 project. we have this hero folder, and hero temp is for like our builds and everything. So we'll create a folder for it, but we won't actually like take this stuff. Like we don't want these builds. So let's first take over hero. So copy. Let that do its thing. It's going to take a little bit of time. We do have a good amount of content in there. So a couple minutes on that. And then, yeah, in the meantime, we can make a new folder, just call it hero temp. I don't think it's going to take 10 minutes. God, that'll be very upsetting if it takes 10 minutes. Okay, about 60 seconds. Here we go. You know, most of it is just like, you know, textures and all the art assets from all the marketplace stuff that we bought, and like a little bit is our code. Just a little fragment of it is our code. Okay, now it's doing some bullshit where I don't know what dictates like how fast it's doing what it's doing. We're just about there. Boom. Okay, now we have Project Hero. Let's right click on our project. Make sure it's using the right version. So yeah, it's using source build 5.1. We'll say okay. So that's all well and good once it's done. Guess it's going to take a little bit. There we go. Now what we need to do, we're going to take binaries, we're going to take intermediate, and we're going to take saved, and we're just going to delete them. And then we're going to just generate again one more time. That just cleans out any of the precompiled stuff that we were doing for 4.27, kind of starts it off fresh. So then what we can do is open up our solution file again. Let's clean up recycling bin. We'll let writer handle what it needs to handle, the initial opening of it. So there's, I don't know why there's two, I don't know why the README split like that. That's kind of weird, but okay. So we'll close that. And what I need to do personally is we got to go to, oh yeah, I forgot. We forgot our plugins. So we have to open up our plugin stuff again. So let's go with our 427 build. So under engine plugins, there's a marketplace folder that we have to create for the, because in our case we have a couple of different marketplace plugins that we need to use. This isn't stuff like the gameplay ability system plugin. These are like the darker nodes plugin and all that, like, you know, other stuff that we're, you know, paid for free. So yeah, let's go Unreal Engine plugins, and here we don't have a marketplace one. We just have to copy over. Let it do its thing as well. Okay. Now we can reopen our solution file. And now we have to change a couple different things. And double check some things as well. So automatically hero is in here. It's included under games because we associated that U project with this source control engine build. So it's going to load everything here for us. So the stuff that we have to do is under plugins. We're not going to see the marketplace folder for a little bit. It takes a long time for it to kind of load in. So you do have this extra thing for writer, which shows all files. We have this marketplace, and now we have stuff like darker nodes, electronic nodes, and magic node. And for all of these, we have to go to the .u plugin folder file and change the engine version. So we got to change it to 5.0.1. That's the one we're currently on. So we got to do that for each one of those plugins. Otherwise, it's going to give us a problem. So there we go. That's all well and good. So we can not show all files again, just to make things clean for us. Now we have our source, a bunch of stuff. That's our project. So we have hero.bat. We don't need that. We don't need to look at that. Sorry for that. So right now it's processing files. Let's just double check our U project, file version, engine association. I think we don't really care for any of that. I think that's fine. We can look at our hero target stuff. I think there's nothing we need to change there. Maybe hero.build.cs. I think that's all well and good. So I'm pretty sure that's all we need to do. There might be some problems. I'm not 100% sure. But we can at least try to build, and we can kind of just figure out our issues as they come up. So now, instead of saying UE5 at the top here, we can find hero. It's going to be alphabetical, so here's project hero. And then we can try F5 in writer, and we'll see what happens. Thanks a lot for the follow, Ankit3009. I appreciate it. So right now, yeah, we're trying to figure out what's going on. We got hydrate. You got it. I have a little bit of water. All right, so we have some problems. So expecting to find a type to be declared in module rules for darker nodes is defined by, okay, so the darker nodes is giving us a problem. Let's see. Now we have to kind of figure this out. Thanks for the gifted sub, Sandra, much appreciated. So let's figure this out. So darkernodes.build.cs, like this shouldn't be a problem if you don't have this plugin. So maybe for the sake of testing, we can go to, is it in here? So we have hero.build, then we have the target. Is it in the U project? Yeah. So darker nodes is the problem. Let's say false for now. And let's just see if we're able to build. Okay, so still a problem. Interesting. Even if we make it false. I just want to see what the problem is. That we're getting these warnings. I always forget. How do I... Here we go. So warning, unknown platform, Win32 while parsing allow list for module descriptor. So let's look at what this problem is. So it's in the U plugin. So platform Win32. I wonder also, let's take a look. Let's take a look at this one specifically. So I have this darker nodes plugin, right? So install the engine. So there is one for 5. So let's install that to that version. And let's see like how it actually sets itself up. So this is my version that we got from GitHub, and I think it's this one. So engine, plugins, marketplace. Here's the darker nodes. It still says it's cleaning it up. So let's give it a couple of moments here until it's finished, I suppose. I guess we can look at the downloads thing, see what... All right, it's just like not doing anything. Because we could just kind of copy the darker node stuff that we're installing into this engine version and just drop it in and try to recompile. We'll have to see. Okay, so it just finished. So I guess we could kind of do a comparative thing. So version name, okay, so this is the problem. So let's kind of copy this and paste it in there. So electronic nodes is also doing the same issue. Interesting. Okay. So let's try. So we got rid of the darker nodes problem. So let's do the same for we don't even need magic node. Honestly, I don't use that one. We'll do it anyway. We'll handle it anyway. So electronic node, install the engine, and then the magic node, right? So we'll let the stuff handle it so it's cleaning up. This is queued. It's gonna probably take a while to do the full cleanup. I don't know why it's doing anything. Well, let's actually close out of everything. And let's do this instead. So basically we have the base version that we have from the launcher, and then we'll have our version from GitHub. And basically we'll override everything. So plugins, and then we have marketplace. So let's just nuke everything like that. Magic node seems to have just finished. I think it might be doing cleanup. Yeah. So we'll wait for that. And I think we can literally just kind of copy paste. We might have to delete binaries, intermediate again, regenerate, open up the solution, try to compile again. So we're almost there. Maybe. I'm gonna get some water. I'll be right back. Your boy's got some of that water. All right, so magic node finished. So we can just literally move it, I guess. I guess that maybe not move it was probably not the best idea, but we'll just copy it back over. Okay, so we got that. Now, let's go to hero. So binaries is still not there. Saved and intermediate are, so let's just nuke that. Let's just, again, generate project files. And then we'll open up the solution, and we'll try compiling again. We're definitely on the cusp of greatness. We're almost there, I hope. Because, you know, once we're able to actually open up the editor in our project, then it's like, okay, is something significantly broken from there, you know? Okay, so we have everything. Good, good, good. We'll let it's preparing the solution structure. So we'll give it a couple of minutes to load exactly what it needs to load, because right now we can't even try to compile. It's kind of grayed out up there, so it needs to prepare everything it needs to prepare. So far, we're almost at 4 hours from start to finish. So let's hope it doesn't get past. I'm thinking another 30 minutes will be the, like, if everything goes smoothly, maybe like 10 minutes. But, you know, we'll have to like prepare for the worst. So it's loading symbols, blah, blah, blah. Indexing everything, caching, blah, blah, blah. So I kind of want to let it do its thing for a couple minutes before we try to compile and build everything. So doing a lot of caching and processing. So close. Updating source files. So your solution contains that is supported by, so reference to Microsoft.extensions.logging that is supported by plugins. Okay. Accept. So restart to activate plugin updates. Oh, that's upsetting. All right, let's restart. So we gotta wait again. Yes, UE5. Almost there, I promise. It's constructing additional pylons. Okay, preparing solution structure like it was before. I'm curious if I even have the right, like I guess I do have the right version of Writer for Unreal 5 because it compiled. Like it didn't give me any kind of problems. Starting code analysis, syncing project, blah, blah, blah. No explicit warnings just yet. Okay, now it's caching. We'll let it do its thing again. Don't want to have it do too many processes at one time. And basically, because of how long the stream has taken, I won't do the Perforce setup tonight. I'm gonna stream that, but that'll be just a different video. Or a different stream. Like if I make a YouTube tutorial about it, maybe I'll include it. I don't know. Maybe it'll be better for it to be a separate video. So we'll see. But for sure, you know, once we're able to open up our editor and kind of confirm that everything's okay with our project, that's kind of where I'm gonna end the video and the stream. Just giving you the heads up. Processing stuff. It's almost done what it's doing, I think. I don't know what git logging really is, but processing Unreal Engine source files. I think that's gonna take a long time. I think we can try to compile now. I think actually, yeah, we actually, let's stop. Can I cancel? I want to enable darker nodes. Try it. Okay. Hero editor. This is very nervous. I'm so nervous. I don't know what's gonna happen. Let's have faith. Okay, so 87 things. Okay, that's just a warning. Whatever, we're good. Don't have to be scared about that. Okay, almost done. Of course it gets stuck when I say it's almost done. Okay. So already bad. So we got a compilation error. A lot of them. Interesting. So yeah, now we gotta fix a lot of these problems. So it's gonna finish what it's doing, and then we gotta figure this out, which is shitty, but okay. But you know, it's expected. Fine. Okay. So hero gameplay ability at line 23, L undeclared identifier. So is it this function thing? Let's get rid of that. And let's just see if, so let's see if it's okay to compile the crouch. Because maybe they deprecated that code snippet, like you can't use it like that anymore. So let's see. Okay, so it is gone. There's no more crouch. So okay, let's try to do this in all the ones. So it exists in the hero interactive foliage. Yes. Let's get rid of that. Hero character preview. Yes, same thing. So I don't know what we can use instead, but for now, whatever. Character movement component. Yeah, this function. Something like that is okay. Compass component. Again, yeah. I'll have to see what to use instead. Well, well, I'm not saying no. They didn't remove crouch. They removed this function, this thing you can write, like the to underscore function underscore. It like explicitly just says where the function's coming from. This is where the compiling is giving a problem. I guess it just doesn't exist or work the same way anymore. Crouching is still the same. Sorry if you misinterpreted that. So we got 35, we just took care of 44. 58, yeah, here and here. Okay, oops. Okay, so that's 58, 61, 80. Oh man, I put this everywhere. Okay, so 84, and then hero player character. So yeah, log hero warning, blah, blah, blah. Okay, we can just print out the character name. Oops. Oh my lord. Okay. 84, 328. Blah, 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 like that. Cool. 345. More or less the same thing. Okay. 376. We don't really need that. And 383, same thing. I think that's it. Let's try compiling now. So definitely interesting that they got rid of the underscore function, underscore, whatever. I don't know what you would call that, but maybe they changed it. Look it up. UE5. Build failed. Nice. Okay, so there's more instances of it. Okay. Keep going. Was really hopeful about that, but we were wrong. I guess it only shows like a certain amount of errors at one time. Okay. So 534, 542, 548, right? Okay. 573. Okay. That's upsetting that it's in so many places. Can you search the entire code for that type of function? I think so. But I'd rather just do it this way. I just want to get explicit errors. So there's going to be one in the hero weather system as well. But let's just compile again. Let's just make sure there's no more underscore underscore function problems. Okay, so hero character movement component, unexpected end of file in macro expansion. Oh, whoops, forgot a parentheses. Classic. But I'm assuming there's going to be an error in the weather system thing. That's what I saw. Or maybe it'll just be broken when we open up the scene. But I'm kind of glad we got some compilation errors. All right, here we go. Cannot convert UE math T vector double to constant F linear. Okay. So let's look at this function. So it takes world context, a collection, the F name, and then a const to F linear parameter value. Okay. So we have to make an F color. Can I just do like F linear color? Whoops. Like F linear color. If I do like an explicit thing like that, let's see. Because also, like, I don't know, because this is wind offset. So I'm not sure exactly what to expect. Okay. Well, we got warnings. So hero attack notify. The file modules are missing are built with a different version. I think that's okay, right? Or does that fail? All right. Please use the other notify function instead. Please update your code to the new API before the next. Okay, so what's the other notify function? All right, we gotta fix a couple of stuff. So our plugins are still kind of fucked up. So you atom notify, please use other notify function instead. What's the other notify? Let's find that out. Let's look at you atom notify. So is it receive notify? So deprecated, please use the other notify functions instead. I don't know which one is that. Receive notify? I guess we have to look this up. Let's copy that. UE5. Okay, there's no information there. UE5, C++, notify. Is there anything in C++? So receive, notify, begin. Do I have to maybe use those? All right, I'm going to assume it's this one. Let's see, generate ignition or not, okay. That's kind of fucking weird. Can I say override? No. What are the other notify functions? My assumption is those other ones. This is annoying. Okay, so maybe it's this one. Okay, so it's only referencing this top one. Override. Generate. Okay, so it already exists. You just gotta do this instead. And I think that's it. And now, I'm pretty sure now we have to go back into our plugins, marketplace, darker nodes. Do I just have to be like 5.01, electronic node, 5.01, and then magic node, 5.01. Let's find out. Was Crouch somehow connected to a notify? No. Where are you getting all this Crouch stuff from, Sandra? That has nothing to do with that. This was like an old notify that I was using for attacking, but we kind of dropped our combat state, so this is kind of like old logic that we're kind of seeing issues with now. Okay, we're still getting warnings. So the darker nodes was designed for build 5.01. Attempt to load it anyway. Yes, yes, yes. So the following modules are missing or built with a different engine version. Okay. So now this is kind of annoying. Okay. For the sake of testing stuff, let's just make this false. 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 Maybe we don't even want, like, we don't have to worry about these plugins right now. Because, like, unfortunately, yeah, these plugins, they were for, like, install engine. You cannot install this plugin. It has already installed to all like, it's not compatible right now. So maybe we just have to wait on those for a little while. Because, again, we're on 5.01, not 5.0. So maybe the developers of those plugins just need time to actually update it. We'll look into that a little later. But for the sake of our own kind of demonstration, we'll just open up the editor now. And let's see what happens. Okay. So far, the window editor is frozen, so that's not good. So we'll let it do its thing for a second. Okay. Doing something. Okay, it's building navigation. Okay, the grass is coming in. It's preparing mesh cards. I don't know what that really means. Okay, so it's doing a lot of shit right now. Preparing shaders, so it has 10,000 shaders. Yep. Okay. So I guess we have to let it do its thing. So derived data cache. Let's change cache settings. Let's make our derived data cache pile. Not pile, but section. So we'll do it, yeah, within hero. So there is derived data cache, so we can literally just say this. We won't restart right now. I'll restart later. Okay, so the project looks more or less the same. The sky is broken, but maybe that's what it's shader, like what the compiling of the shaders is messing with. Maybe it's the sky. We can try to play. Okay. See, yeah, still compiling, but it's more or less there. Okay. So we'll let it compile, and we'll kind of chill. But, you know, I'm pretty happy that everything's okay. Okay, so there's our character. And the stream quality is still good. Like, there's no real hiccups or anything. The gameplay ability system is in place. So very nice. The wolf is kind of just chilling. And I think that's really everything, yeah? Okay. So yeah, let's wait on the compiling. Oh, and then we're dead. But yeah, all our content is here. See, there's no blueprint compilation errors. The only thing I'm nervous about right now is the sky. Because we did have to change that one thing within the weather system. So I am kind of curious. And yeah, in terms of like the magic node plugin and the darker nodes plugin, like we'll just have to wait, I think, on those. It's not a big deal. I don't know what I should do for those, honestly. I try to figure that out on my own. I don't think is worth my time. Just let the developers of those plugins handle it. But we can at least open up Sprint, maybe. Yeah, first time opening up this editor. It's pretty brutal. So yeah, no more darker nodes plugin and the electronic nodes or whatever. Not a big deal. It'd be nice to have, but I can try to figure out, in the meantime, obviously, like it's still doing. Yeah, now it's preparing 13,000 shaders. I guess maybe in the meantime, but at least we could say for one, hey, we did it. But we could in the meantime maybe say UE5 how to compile plugin. There is a video.
Some older plugins kick out this error. The error will appear every single time you open the project unless you compile it for the new version of Unreal. In my case, I'm using the Arduino plugin. Link in the description. Just download the zip file and extract to a folder. Once you know where that folder is, we can use the command prompt to recompile the plugin. We'll need the path to the plugin, so we'll just copy that from here, Control-C, and then Windows key CMD to launch the command prompt. Hit Enter. So E:, Enter. That'll get me over to my E drive, and then I just do CD, EP tab, UE tab, EN tab, BU tab, BA tab. That gets me to where the batch files are. Now
Jesus Christ.
Followed by build plugin. Now we just need two parameters. The first is -plugin equals quote and then start path.
This is rough.
/UE tab to include the plugin file. The final parameter is -package. I'm just going to paste.
All right, let's try this. Let's see. So let's close the editor. And let's also, let's enable darker nodes, for example. We'll say that's true. So we need the path to that plugin. So it's going to be under here. Engine, plugins, marketplace, darker nodes, right? So we're going to copy that. And then what we need to do, we need to go to engine and build. So engine, build, and then once we have that, we can say CMD, opens that up, and then we can do run uat.bat build plugin -plugin equals blah blah blah.
With /UE tab to include the plugin file. The final.
And then we have to include that uplugin file. So yeah, let's close out of the writer just in case that's a problem. So engine, plugins, marketplace, darker nodes, and that. So basically, after darker nodes, we have to say /darker nodes .uplugin.
Parameter is -package. I'm just going to
and then -package.
path, followed by a new destination folder, UE4Arduino 425.
Okay. So after the quotes, we say what? -package. Yeah, -package equals, like similar directory, make a new folder. UE5. Cool. Immediately wrong. So it's under build, batch files. Oh, I forgot batch files. Okay. I mean, do I have to really type all that in again? Oh, that sucks. Okay. let's try this. So engine, build, batch files. There you go. There. Run uat.bat dash plugin equals quotes slash darker nodes dot u plugin dash package equals, and then UE5. I also forgot run dot bat and then build. Oh, fuck. This is hard. So we gotta do bash files. So we do run uat dot bat build plugin dash plugin equals quotes like that slash darker nodes dot u plugin dash plugin package equals that slash UE5. It's doing something. So output directory for package plugin must be outside engine directory. Okay. So we'll do it in this directory, maybe. Does that, I think it's outside of engine directory, right? Fingers crossed. That's kind of interesting. I didn't know you can actually build plugins like this. So I guess you learn something new every day. Okay, so building. Now we gotta check how maybe it's gonna fail, maybe it's not, who knows. Okay. Success. Okay. Let's see what happens. I don't know. So we enabled it in the .u project, but I wonder, like, do I have to explicitly say which one to use? Or do I have to, like, kind of copy that one that's compiled now into that? Don't know. Let's try. Let's just try compiling. We just have to wait for it to finish its code analysis and everything. So fingers crossed. If we can get this to work as well, that would be super nice. I'm going to use the bathroom real quick. Hopefully by the time, well, yeah, I'll use the bathroom and then we'll try compiling. All right. Let's try. So we should expect success, but we are going to see if we're going to get that warning come up. So here's compile module dark nodes. So build succeeded. I think we're okay. Let's see. Because if that worked, then we could do it for the rest. Just the magic node and electronic node. Of course, it needs to compile shaders. So many shaders. I guess it's because of the darker nodes. Okay. So we have darker nodes version 3. Hello and thank you for using it. Cool. Close this window. Now let's look at the blueprints. Of course, that's going to take a while to open. Gotta love it. And yes, we got the dark nodes plugin. That looks correct. It all has that interface. Everything kind of looks like it is. So now we have to do the electronic one. So let's close out of that. Close out of writer. Let's now let's create a new one for electronic nodes. So how do we write this again? Okay. Engine. Okay. So let's go back and yeah, so there. Engine, Unreal Engine, engine, build, batch files, cmd, run UAT .bat build plugin dash plugin equals. Then need to find the plugin. Plugins, marketplace, electronic nodes, like that. So double quotes, end it with electronic nodes dot view plugin dash package equals, and then we gotta go to where we want to put it. It has to be outside of the engine directory folder. Hero, plugins, electronic nodes. And that should do it. And then if that is successful, then we then go back into Writer. We'll enable that plugin again. And we can do the same thing for the Magic Node plugin. Even though we don't use the Magic Node plugin, we're just going to do it anyway for funsies. But yeah, that's a super duper helpful video, so I'm just going to hit that with a thumbs up. Okay, success. Boom. Okay. Let's open that up. Oh boy. Can I close that? Thank you. All right. I'm actually pretty excited. This was more or less painless. You know, this was very time consuming. So you project electronic nodes, true. maybe in the meantime, while that's kind of loading and everything, let's prepare the information. So run uap.bat build plugin dash plugin equals. I know you're not really seeing what I'm doing. So let's go here, 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 marketplace, magic node, / magic node.u plugin, right? Then that dash package equals, let's go to hero, plugins, magic node, spell that right, magic node. So that should be it. So, okay, so let's build. Let's just make sure the electronic nodes plugin is working. Finally, the light at the end of the tunnel, you know? Very nice. And then there's, you know, some other future problems that we gotta kind of look into. Like Nanite, if we want to use Lumen, well, we have to convert our cascade particles. The whole 9 yards will be kind of annoying. Okay, I guess I can get that ready. I'll have that copied to my clipboard. And we have batch files, so we can open that up again real quick. Okay, we got the electronic nodes one. We discover darker nodes. This fix faster activation without reload. Don't care about that. Honestly, I'm gonna let the shaders compile at some point, but not right now. So let's look. Of course, yeah, it's gonna take a second to open. And there we go. We have the electronic nodes, like the sharpness of the nodes, so we know that works as well. So boom, great. Last but not least, let's do magic node, even though we don't need it. Since we had that copied into our clipboard, we can easily copy paste that. Definitely gotta save this video for watch later. It's good to know. Why does it has to do 16 actions? Damn. Magic Node's doing some weird stuff. I also don't know how I'm gonna really splice and edit this video so that's a more concise tutorial, because a lot happened that I wasn't really expecting, like these plugin issues and stuff like that, but probably still useful. Definitely gonna cut out, you know, those long compilation times in between, you know, when we had to compile, when we had to do the cloning at the beginning, and then when we had to actually compile the engine, and, you know, we can all skip through that. Like 3 hours worth of random ass waiting and content watching Unreal 5 related videos. Okay, these are warnings. That's fine. Sometimes it just, like, yeah, I have to press enter for it to, like, update what it's doing. Which is weird sometimes. I don't understand that with the command. Oh, 15, 16, yeah, okay. Build failed, okay. Very nice. We don't even use this node anyway, so I don't care. But what's the problem? It's like monolithic headers, it's a warning. So Android toolchain NDK R21B recommended. Platform Android is not a valid platform to build. Check that the SDK is installed properly. So that's the problem. So more details here. Let's look at it. Take out the parentheses. Not parentheses, maybe parentheses. So Android toolchain. So let's go to Visual Studio Installer. Let's modify. Let's see if we can find the Android SDK thing. So we're looking for mobile development. Yeah, Android NDK. Okay, so we need 21. R21B. So I don't see that one. So there's only 16. So let's not do anything like that. Let's look it up. So Android NDK R21B. So it's 23, 24. Where's 21? It's kind of weird. So all right, so this is 21E. Where's 21B? That's kind of weird. I mean, maybe I can just get the latest one from Visual Studio Installer and that's fine. Let's look. So modify. Let's close out of stuff. So mobile development, sure. Modify, yes. So let's see what happens. Hopefully it's cool. All for a plugin that we're not even using. You know, don't want to brag, but we're doing something stupid. Okay, so now it's downloading stuff. Cool. I don't know, like, I don't even know if I'm using 2019 or not, because I have both 2017 and 2019, but I'm using Rider. So I don't know what toolchain it's actually using explicitly. So it's almost done. And yeah, again, I don't know if I have to also modify 2017. We're going to just do 2019 first, rerun that command and see what happens. And it's definitely taking its time installing all the packages and stuff. Okay, so everything's downloaded. Now it's just installing. So now we play the waiting game. But yeah, pretty much we accomplished what we needed to accomplish. We're able to open up the project. Now we're just doing all the what's the word? Housekeeping stuff. And we're learning a lot of stuff along the way. Okay. Stupid Instagram meme. Okay, my food is also here. I'll be right back. So I'm going to stand here, and we're going to wait for the packages to install, and I'm going to wait for the food delivery, and we'll see what happens. You know, I guess I'll eat on stream or something, but I don't know if you want to watch me eat buffalo wings and shit. It's almost done. It's finishing up. I'm just gonna eat some fries in front of you. I don't want to eat boneless. I don't want to eat boned chicken wings. It'll be too fucking messy to do it on stream. I don't want to gross people out. So I'll just have some fries. All right. Let's try again. We might have to just do general updates as well. All right. Let's cross our fingers. Okay, so it's gotta do 16 actions again. I really hope this works. Okay, no, all these monolithic headers, bullshits, nothing we have to really concern ourselves about. Yeah, that needs to, yeah, I need to do a game dev mukbang in a hot tub. I think that's gonna break the internet. That's like the next level. Okay, it failed again. Nice. Okay. So I think I'm gonna stop streaming. I'm gonna update everything. I'm gonna do the same thing for 2017. We'll see. Again, I don't use that plugin, so it doesn't matter. But we were able to successfully migrate our project from 4.27 to 5, from start to finish. So I'm very happy about that. Sandra, thanks so much for hanging out and going through that process with me. Next time we stream, we're gonna set up the Perforce repository. And then, depending on how easy that goes, we'll set up Jenkins and we'll set up Unreal Game Sync. And then we should be good to go. So that's where I'm going to end the stream. If you aren't already, follow me here on Twitch. Keep an eye out and follow me on YouTube as well for the tutorial that I'll try to make from this stream. And then, once everything's good to go as well, I'll update the GitHub repository with everything correct, and then we're good to continue game dev. So, have a good night, enjoy your Monday, and see you soon.